Hello everybody, welcome to the Coopersmith Career Consulting College Algebra Review course. Of course, this assumes that you have a basic knowledge of college algebra and all the subjects that we're going to go into, but what I'm going to try to do is I'm going to try to go through some examples of all the different subject matters that you will need to know in order to pass the final examination for this course. So let us get started. Okay, and hello. And before we actually start with our crash course and the material that you're going to need to know to do well in this exam, in this course, I think it's a good idea to give you a little bit of a refresher, and I'm just going to be going through some basic stuff regarding algebraic manipulation, the sort of thing that you're really going to need to know. Hopefully you know a lot of this stuff already. If you don't, that's okay. I'm going to try to take it through it with you as much as possible. And again, I do apologize if the next few minutes of this course does seem a little basic because, well, it is a little basic. Anyway, the first thing that's very important that you need to know for algebra is the concept of Pemdas. Now, Pemdas is also known as the order of operations. Order of operations is what happens when you have many arithmetic operations to be formed at once. You know, just to give you a very, very simple example, there was an example on Facebook that I noticed posted a few times where there was a question like 5 plus 5 minus 5 plus 5 plus 5 minus 5 plus 5, or something like this, times 0. And they asked you what the answer is, and a lot of people said, well, it's 0, because anything times 0 is 0. So regardless of all these 5s, when you get to the end and you multiply by 0, you're going to get 0. Well, unfortunately, that's not the answer. I guess it really doesn't, not unfortunate or fortunate, but that's not the answer, because in the order of operations, multiplication comes before addition. So therefore, when you're doing this problem, the first thing you would do is do the 5 times 0, which gives you a 0. And then you would do all the additions. So you'd have plus 5, which is 10, minus 5 is 5, plus 5 is 10, 15, minus 5 is 10. So the answer would actually be 10 in this case. So Pemdas is, but that's just the order of operations is when you have a whole bunch of these, what do you do? What do you do first? Now, Pemdas stands for, the P stands for parentheses. I'll write them on the side over here. I'm sorry, just give me 1 second. Okay, there we go. Alright, P is for parentheses, E is for exponent, M and D are multiplication and division. Now, multiplication and division, by the way, are the same thing, just different forms of really the same operation. And the last two are also addition and subtraction, which are the same thing. So there are really 4 operations here. There's parentheses first, then exponents, then multiplication and division, then addition and subtraction. And the reason why I put them together, by the way, is that if you have both multiplication and division, the order doesn't matter. You want to do the division first, that's fine. You want to do the subtraction before the addition, that's fine also. They're really the same operation. Just to give you an idea, what if you have something like 3 plus 7 times 3 plus 2 to the second power, and then all divided by 6, let's say. Actually, that's a bad example. Let me get rid of that. Let's say plus 8 divided by 4. And generally, you can use a fraction instead of a division sign. Alright, so under Pemdas, the first thing you would do is your parentheses. So that would be the 3 plus 2 over here, and the 3 plus 2 would become 5. There's no more parentheses because this is now eliminated. So the next thing you have is your exponent. Now, your exponent is 5 times 2. 5 squared, 5 to the second power is 25. So we'll make this into 25. Then you have your multiplication and division. So you have, for the 3 stays where it is. Now 7 times 25 is 175, plus 8, and remember you can't do the plus yet, you have to do the division also. 8 divided by 4 is 2, and now you can do your addition. 3 plus 175 plus 2 is 180, and your final answer would be 180. If you did it in a different order, if you did the exponent first or anything to that effect, you would have gotten the wrong answer. It's very important whenever you're multiplying out something, whenever you're doing an operation that has several components, you need to remember these order of operations. They also become very very important when you have, when you have variables. Now, variables like letters, when you have letters, they're going to be it's going to occur much differently, but the same basic structure has to apply. If you have x times y plus z, and y is to the second power, if you can multiply these things out, if you can do operations with them, well, then you need to do them in this order. Now, in this case, without any further information, you're not going to be able to do anything with these things. But the fact is that if you could do something with them, if you knew what the variables were, for example, or if the variables could be broken down, you wouldn't need to do this order. You would need to do parentheses first, then exponents, then multiplication and division, and then addition and subtraction. Next, let us look at basic substitution. Now, this again is going to be very, very basic stuff. But let's say we have something like x times y plus z to the third power minus q. Now, these are all variables. Notice in math, whenever you have a letter, it means you don't, originally, at the beginning, you don't know what the letter is. Later, hopefully, you can find out what that letter is sometimes. But variables always mean things that you're not immediately told what those numbers are. There are some symbols, by the way, that are not variables. For example, pi is a letter, but it's not, well, it's a Greek letter, but it's not a variable. Pi is a specific number. It's 3.14159, etc., etc., etc. So just because it's not a number doesn't necessarily mean it's a variable. A variable means you don't know what it is, and therefore you usually use a letter to indicate it, that it's some kind of unknown. It's some kind of variable. You don't know precisely what it is. And you use different variables when you're talking about different numbers. Now, for example, in this case, there are 4 variables. There's x and y times y plus z, and then there's q, which are 4 different variables. They could be 4 different numbers. Sometimes you'll have an expression with the same variable repeating itself. For example, you'll have x times x plus z minus yq. Now, in this case, you've also got 4 different variables. You've got y, q, x, and z, but x shows up twice, and that's okay, but the x's are always going to be the same as each other. The others, of course, are generally going to be different. Now, if you're fortunate to actually get the numbers, to get what each number is, then simply plug it in. For example, if they tell you that x equals -2, and y equals 4, and z equals 1, let's say, and q equals 12, well, then you should be able to relatively easily just plug it in and figure out what everything is. So in the top one, you have x is -2 times y plus z, which is 4 plus 1 to the third power minus q, which is 12. How would you do this? Well, remember Pemdas. What's the first thing? Parentheses. 4 plus 1 is 5. To the third power, so you'd have -2, still, you can't do anything with it because you have to do the exponent first. 5 to the third power is 125 minus 12. Now you can do the multiplication. You've got multiplication and subtraction. Multiplication comes first. -2 times 125 is -150. Minus 12 equals -162. Let's see the one on the bottom. We've got x, which is -2, times x, which is -2, plus z, which was 1, minus yq. Now, whenever you have 2 variables next to each other, or a variable next to anything for that matter, you have whenever you have 2 variables next to each other, that is considered multiplication. So yq means y, which is 4, times q, which is 12. So again, what do we do first? We do the parentheses. -2 plus 1 becomes -1. There's no exponents here, so now we can just do the multiplication. -2 times -1, a double negative, becomes +2, minus 4 times 12, which is 48. And so it's 2 minus 48, which becomes -46. Okay, now a number that is next to a variable, let me just clear the board over here. Okay. I'll start a different color here. We're doing a slightly different thing. A number that's next to a variable is called a coefficient. You're going to hear me refer to that term a lot. 3x, 3 is the coefficient and x is the variable. 17y, well, now we've got the 17 is the coefficient, which is the number next to the variable, and y is the variable. We don't know what it is. Sometimes one term will have multiple variables. For example, 3xy. Now, 3xy means you got one coefficient, one constant. Numbers are sometimes also known as constant because that's as opposed to being variable. Variable means you don't know what it is. It could change based on the circumstances, based on the rest of the equation, whereas a coefficient, a constant, a number, is always that number. So you have one coefficient and you've got two variables, 3xy. Now this, of course, also means 3 times x times y. If I wanted to say 3 times x divided by y, I would say something like 3x over y. And this is also one term. 3x over y is also really the same basic idea as 3xy, except that instead of having the y being multiplied by the term is being divided by y. And now we start getting to the fun part, and that is manipulating variables. Until you start with manipulating variables, it's not really algebra. What we've been doing for the last few minutes wasn't even really necessarily algebra. Where it gets to be algebra is where you take variables and you're able to manipulate them a little bit. Let me give you an example. What if we have 2x plus 3y? Is there anything you can do here? The answer is no. You can't do the 2 plus 3 because 2 has a coefficient, 2 is a coefficient, it has a variable of x, and the 3 has a variable of y. In this example, if you're doing a problem and you come up with 2x plus 3y, well, that's your answer. There's nothing more you can do with the 2x plus 3y. You can only add or subtract variables or terms if they have the exact same variable. So if I have, for example, 2x plus 3x, well, this is the same variable. X is the variable. In this case, what you would do is the variable stays the same, and the numbers simply get added. So 2x plus 3x is 5x. Just like, of course, 2 plus 3 equals 5. Do these have the same variable? Yes, they both have no variable, so you can add them. 7 minus 4 is, of course, 3, and so therefore 7y minus 4y equals 3y. What about 2x plus 3xy? Is there anything you can do with this? The answer is no. They do not have the exact same variable. This has an xy variable, whereas that has an x variable, and so therefore the entire term stays the way it is. If you have, let's say, 6xy minus 12xy, well, now they've got the same variable. They both have the xy, so you can simply add or subtract the coefficients. And 6 minus 12 is, of course, negative 6xy. What if you have something like this? Just plain q plus 7q. Is that the same variable? Well, yes, it is. If there is no coefficient, as in this case, what is the coefficient? The coefficient is presumed to be 1. 1q is the same thing as q. 1x is the same thing as x. So in this case, the answer, of course, would be 8q. Doesn't matter what the variable is. If the as long as they're the same. If the variable has an exponent, for example, if we have, let me write one down here. Let's say we have 3x squared plus 6x. Is there anything you could do here? The answer to that is no. You cannot do anything because the variables are different. One of them is x squared and one of them is just plain x. If we have 3x squared plus 12x squared, now we've got the exact same variable, so now we could add them, and your answer is 15x squared. What if you have, let's say, 8x squared y minus 5x squared y? Well, now you've got the exact same variable. X squared y is the variable here, x squared y is the variable here. You can combine them, and 8 minus 5 is 3, and the variable would stay the same. On the other hand, if you have a very similar variable, but that has one slight difference at the end, you cannot combine them at all. So if I have 4a, b, c, d, x squared, y, z, plus, we have 4abc squared xyz plus 3abcd xyz. You can't combine this because this had the c squared, abc squared xyz, and this one didn't have a c squared and it had a d. Even if I would cut the d, even if I would just make this abc xyz, I still couldn't combine them because this had a c squared in it and this didn't. If you got to this point in an algebraic function or an algebraic expression, you would just have to give this as your final answer because there's simply nothing else you could do with this term. You couldn't add it. Okay, now let us move. So that's adding or subtracting. Again, fairly simple stuff. Now let's move on to multiplication of variables. Again, I'm going to change the color over here since we're changing topic a little bit. So let's say we have x squared times x to the third. Now, this is a multiplication case. If it were x squared plus x to the third, nothing you can do about it because there's different variables. If you multiply, however, as long as you have the same base, in other words, x in this case, this one the base is x and this one the base is x, you can multiply them. And to multiply them, you simply add the exponents. So x to the second times x to the third is x to the fifth. Now, x to the second times y to the third, nothing you can do about that. That's just plain x squared y cubed, and that's your answer. Nothing you can do about that because that is because the bases are different. Division is the opposite. If you have x to the seventh divided by x to the fifth, so you subtract the exponents. X to the seventh divided by x to the fifth is x squared, or x to the second. If you have y to the eighth divided by y to the 12th, well, 8 minus 12 is negative 4, and the answer is y to the negative 4. Or, which is the same thing as 1 over y to the fourth. The reason for that is a negative exponent means the same thing as 1 over whatever that is. You know, z to the negative third equals 1 over z to the third. And by the way, for this example, you could have either just said this is y to the negative fourth, which is the same thing as 1 over y to the fourth, or you could just have canceled it and really done it the opposite direction. And, you know, if I had over here y to, let's say, the sixth over y to the ninth, well, now if you look at the thing on the bottom, you can cancel and make this y to the third on the bottom, and this 1 because this cancels out. Think about it this way. Let me give you a simpler way to think about this whole business, and it becomes pretty obvious. So let me get rid of this over here. Start this over here. What was the example I just used? I just used y to the sixth over y to the ninth. What is that really saying? Y to the sixth really means y times y times y times y times y, divided by y to the ninth, which is 9y's. There we go. Okay, we've got 9y's. Now, anytime you divide something, you can always just cancel it. You know, if you have 2 divided by 2, for example, that becomes 1. They cancel. So you could have this cancels with this cancels with this cancels with this. And what do you have left? You've got 3 y's in the bottom and nothing on top, so that just becomes a plain old 1. So this is the same thing as 1 over y to the third, because there are 3 y's left, which of course is the same thing as y to the negative third. What if you raise a power to another power? For example, you have x to the second and raise that to the third. You put that in parentheses to illustrate that the entire term is being raised to the third power. This is really x squared cubed. Well then, instead of adding the exponents, you would multiply. So x to the second to the third power is x to the sixth. What if you throw some negatives in there? Like, let's do another example over here. What if you have y to the negative seventh raised to the second? Well, again, you'd multiply the exponents. Y to the negative seventh to the second is y to the negative 14th. It's 14th, which is the same thing as 1 over y to the 14th. And if you think about it, that's simply because whenever you're squaring something, whenever you're taking something to the second power, you're really just taking two of them. So 1 over y to the 7th, y to the negative 7th means 1 over y to the 7th, which means 1 over 7y's, like this. Okay, well, to the second power means that you're doubling. You're making two of them, which means that's really the same thing as saying 1 over y, because 6, 7, 8, 9, 10, 11, 12, 13, 14, which is the same thing as this, y to the negative 14th. Now I'm going to take you through very basic equations. Now the equations in this course are going to be a lot harder than this, obviously, but let's start off with extremely basic equations. Equation requires that you have a variable, at least one variable, and at least one constant. If you just have plain x, well, that's not an equation because it doesn't tell you anything about x. What does x equal? Also, if you have x equals x, well, that's not really an equation either because you have this doesn't help you at all in terms of getting you what x is. Now, there are some equations that have one variable and some equations that have multiple variables. You cannot solve an equation that has multiple variables unless you have some other information, like, for example, a second equation, or some indication as to what the variables are. For example, if I have 2x equals y, well, I don't know what either one is because there are lots of different possibilities. X could be 5 and y could be 10, x could be 100 and y could be 200, x could be 1,000, y could be 2,000, etc. Now, if we have another equation that tells us, for example, y equals x plus 7 or something, well, now all of a sudden we would be able to figure this out if we have two equations or if we know what y is. But generally speaking, we're going to start, at first at least, we're going to start equations with only a single variable. Now, equation with only a single variable will look something like this. X plus 3 equals 10. Again, this is extremely easy. Even if you knew nothing about algebra whatsoever, you could probably figure out in 3 seconds that x has to be 7, because 7 plus 3 is 10. The way to solve any equation, whether you're talking about a one-variable equation or a multiple variable equation, is to take the variable that you're looking to solve for to figure out what it is, which in this case is x, and get rid of all the other terms. Get your variable on one side of the equal sign, and get everything else, or get a number ultimately, on the other side of the equal sign. So, how do you solve this? Well, in order to get the x by itself, we have to get rid of the plus 3. How do we get rid of the plus 3? Well, you do the opposite of whatever plus 3 is. In this case, of course, that's minus 3. Because if we subtract the 3, well, then there's not going to be any 3 left, and you're only going to have an x on this side, which is good. Now, the thing about an algebraic equation is you can do anything you want as long as you do it to the other side, too. It's a fantastic thing about algebra. You want to do whatever you want to this side is fine, as long as you do it to the other side also. So 3 minus 3 is 0, of course. So you subtract 3 from this side also, and you have x equals 7. Now let's take something, let's say you have the variable is being multiplied. Let's say you have 3y equals 18. Well, we have the y over here, but we need to get rid of the 3, which is next to the y. What's happening between the 3 and the y? Multiplication. Whenever you have a variable next to a number or a variable next to a variable, it means multiplication. So how do you get rid of the 3? Simply divide by 3. If you divide by 3, then the 3's will cancel and you'll have y by itself. Whatever you do to this side, you have to do to this side. 18 divided by 3, and your answer is y equals 6. If it's a little bit more complex, for example, you have 17x plus 12 equals 46, well, okay, well, you might need to take a couple of steps. you might need to first, you need to get the x by itself ultimately. How do you do that? Well, you can't start dividing by 17 now, because you've got other terms. If you divide this term, you're going to have to divide this term too. It's going to be one big mess. You want to get the term, at least to get the x term by itself first. You always want to try to get rid of everything. Before you start touching the x term, you want to get rid of, make it sure it's by itself on the equal sign. So first you want to start getting rid of the things that are further away from the x. In this case, that would be the 12. So, for example, we could subtract 12 from this side, and 12 minus 12 is 0, so they cancel. So we subtract 12 from this side, and we still have 17x, which we didn't touch yet, equals 46 minus 12, which is 34. Now we need to get the x by itself, so we can divide by 17, so that the 17's cancel. 34 divided by 17 is 2. If we want to check an answer, by the way, if we want to know whether an answer is correct, all you need to do is take the initial equation and substitute your answer. Our initial equation was 17x plus 12 equals 46. Well, okay, 17, our x was 2, so we'll make that times 2, plus 12 equals 46. Let's see if that works. 17 times 2 is 34. Plus 12 equals 46. And does this expression work? Well, 34 plus 12 is 46. It does work. So that means we can put a little check mark, and we have the answer correct. Sometimes you have multiple variables in an equation. Let's say, again, to take a very simple one, let's say we have 3x plus 7 equals x minus 1. Well, now we've got two variable terms. Now, fortunately, they're the same variable. If they weren't the same variable, we'd be in big trouble. But so in order to do this, we need to try to get all the variables to one side and all the numbers to the other. Either we can move this term here and this term here, or we can try to move this term to this side and, well, I'm sorry. Well, anyway, sorry I messed that up a little bit. But the point is, we need to move all the x's to one side and all the numbers to the other. And there are two different ways to do that. Either we can move the 3x to this side and the negative 1 to this side, or we can move the x to this side and the 7 to this side. You know, we can try it both ways just to illustrate how they both work. Let's try to first get rid of the x from this side. So I'm going to subtract x from this side. Because remember, you can, if you do x minus x is 0, because anything minus itself is 0. So I can do minus x on this side. So 3x minus x, remember x is really the same thing as 1x. So 3x minus x is 2x. And we still have plus 7 equals negative 1. Then we have to get rid of the 7, and so we can subtract 7 from each side. Because 7 minus 7 is 0. Then we have 2x equals negative 1 minus 7, which is negative 8. Divide each side by 2, and we have x equals negative 4. And we could have done it the other way as well. Remember, at the beginning we had 3x plus 7 equals x minus 1. If we wanted to do the other way, if we wanted to subtract 3x from this side, and subtract 3x from this side, so we'd have 7 equals x minus 3x, which is negative 2x minus 1. Add 1 to each side to get rid of this term. And we'd have 8 equals negative 2x. Again, we want to get, it doesn't matter which side the x is on, we just need to get the x by itself. So we divide by negative 2. Remember, you can't just divide by 2, because then you have negative x. You want x. So negative 2 divided by negative 2 cancels, and you have 8 divided by negative 2, which is negative 4 equals x, and of course that is the same answer. If we wanted to check it, just to make sure we have the correct answer, remember we have 3x plus 7 equals x minus 1. Let's see, we have 3 times negative 4 plus 7 equals negative 4 minus 1. Let's see if this works. Well, we've got 3 times negative 4 is negative 12 plus 7 equals negative 4 minus 1. Negative 12 plus 7 is negative 5. Negative 4 minus 1 is also negative 5. And so that means that everything checks out. Congratulations. If you are dealing with an equation with an exponent, and remember those are pretty common as well. So let's say we have something like 7x squared plus 20 equals 83. you can solve it pretty much the same way. This has a square term. By the way, anytime you're going to have an x squared term, as we'll see later on, you're going to have two answers. Two possible answers are going to be you're going to come up with two answers. Now, as long as you don't have also an x term, if you also have an x term in there, it's much more complex, and we'll have to see how to do that later on. But if you don't have an x term in there, if you just have an x squared term, you solve this like you would any other equation. First you have to get rid of the 20, get rid of this whole term, so you can subtract 20 to get rid of that term. And you'd have 7x squared equals 63. And then, of course, you want to get the x squared by itself. So you divide by 7 to get rid of this term, divide by 7. So you have x squared equals 9. Now at this point, we're not quite finished yet because we have the x term, but we have an x squared. In order to get the x by itself, you can take its square root. The square root of anything squared is itself. The square root means what number squared will get you to that number. For example, this is the symbol for square root. The square root of 25 is 5. Or actually, the truth is, let me give you another example. Let's say we have the square root of 49. The actual answer is there are two possible numbers. It's either plus 7 or minus 7. And the reason why it's plus 7 or minus 7 is because either one will get you up to 49 squared. 7 times 7 is 49, and negative 7 times 7 is also 49. So back to our case, when we have the x squared, we can take the square root of this to get plain x. So we also have to take the square root of this. And the square root of 9 is 3, but it's really plus or minus 3. Either positive 3 squared will give you 9, and negative 3 squared will also give you 9. So the actual answer to this is positive or negative 3. If you wanted to check it, again, what was our example? 7x squared plus 20 equals 83. 7, you can do two different checks because you have two answers, but for argument, we can do positive or negative 3. It's going to be the same thing. To the second plus 20 equals 83. In Pemdas, in the order of operations, what do you do first here? You do the exponents first. Remember, that's very important. Don't do the multiplication first. If you do 7 times 3 first, you're going to get the wrong answer. You're going to get 21, and 21 squared is 400 and something. So you're not going to get the right answer. What you need to do is first the exponent. So 3 squared, either positive 3 or negative 3 doesn't matter. Either way, that's going to be 9. So it's 7 times 9 plus 20 equals 83. 7 times 9 is 63 plus 20 equals 83. And of course, that is correct. So we can put a little check mark, and we've got the answer. Okay, now let's get started over here. Now, first of all, I hope you'll forgive me in advance. I'm kind of new with some of these tools that I'm going to be using over here, so if I mess up a couple of times and have to undo things or correct mistakes, I hope you'll take that in stride. But the first thing we're going to cover is simplifying expressions. Now, simplifying expressions in algebra simply means taking a complex expression and manipulating a little bit using various algebraic methods and making it a little simpler. Now, this is the first example that I have over here. We have 2x minus 5 in parentheses times x squared minus 3x plus 1. And the basic tactic you're going to use with something like this is really going to be the same whenever you have two numbers multiplied by two numbers. In this case, it's a binomial, which is two numbers, 2x minus 5, multiplied by a trinomial, which is x squared minus 3x plus 1. Essentially, whenever you do something like this, whether it's a binomial by a binomial or a binomial by a trinomial, as in this case, everything in this side has to be multiplied by everything on that side. So for example, the 2x needs to be multiplied by each of these three terms, and the negative 5 has to be multiplied by each of these three terms. So let us go ahead and do it. Just this one, again, this is a fairly simple example over here. We need to multiply each term by each term. So first let's use the 2x times the x squared. Now when you multiply the same letter, you can add the exponents. In this case, this is really the same thing as 2x to the first power. and you also multiply the coefficients. In other words, you also multiply the 2 times the coefficient of x squared, which means the number next to x squared. When there is no number next to the x squared, you just simply leave it as a 1. So 2x times x squared is, in this case, 2x to the third power. The 2, because it's the 2 times the 1, which is the number next to the x, which there is none, so it's a 1. And then you have the x times the x squared, and you add the exponents. When there is no exponent, it automatically becomes a 1. So it's 1 plus 2, which is 2x to the third power. Okay, now let's do the second term. 2x times negative 3x. Well, the coefficients are 2 times negative 3, which is negative 6. And the x times the x is, of course, x to the second power, or x squared, because they both have exponents of 1, and so they just add the exponents, and you have 2x squared. I'm sorry, x squared. Okay, now the third one, 2x times 1. Well, that's simple enough. Again, it's a plus sign, because if you don't know if it's just 2 regular, in other words, if there are no negatives, it's just positive. So 2x times 1 is simply 2x. Now let's try the second part. The second part is negative 5 times x squared. Now what I'm going to do here actually is I'm going to put each of the terms underneath the ones that they correspond to. The reason is you can always add or subtract numbers as long as they have the exact same variable. You know, for example, you could not do 2x plus 3 because those are different variables. Here the variable is x, and for 3 there is no variable, so you can't combine those at all. But for example, if you have 2x plus 3x, well, now they've got the exact same variable, so now you can just add the coefficient, and that becomes 5x. Okay, so let me go ahead and erase this down here and come back up here. Now, so getting back to this, so we've got the negative 5 times x squared. So I'm going to put this as the same variable as the 6x squared. So negative 5 times x squared is simply negative, excuse me. Sorry about that. Just got to erase this over here. Okay, now, if we get back here, this is negative 5x squared, because it's negative 5 times x squared. Now we've got the next term, negative 5 times negative 3x. Negative times a negative is, of course, a positive. So you have positive 15x, because 3 times 5 is 15, and just so the x stays. And then you have negative 5 and positive 1, which, of course, is negative 5. Negative 5 times positive 1. The reason why I put it over here is because there's no constant term. In other words, there's no term without a variable. And then you could simply add these expressions, because I ordered them so that each one is with the term that it can be combined with. Nothing can be combined with the 2x cubed. So we're just going to leave 2x to the third power, which means 2x cubed. Next, we've got negative 6x squared minus 5x squared. So negative 6 minus 5, of course, is negative 11. So we can just leave the variable because they're the same variable. And we have negative 11x squared. 2x plus 15x is, of course, 17x, obviously. So this is also a plus 17x, and we have minus 5 at the end. Now, there's really nothing we can do to simplify it over here because they've all got different variables. This has an x cubed variable, x to the third power. This has an x squared variable. This is an x variable, and this one has no variable at all. So there's really nothing that we can do but just put a big box around it. Whoops. Okay, it should be around it. Anyway, this is our answer, 2x cubed, because we just simplified by multiplying everything out. And this is really, there's really nothing you can do to further simplify this problem. Our next idea of simplifying expressions is the opposite, division. Division is really very similar to multiplication, except it's the opposite. And I'll give you an example over here. This I chose 36 x to the third power times y to the fifth power divided by And over, of course, means the same thing as divided by, negative 2 x squared y to the 7th. Okay, so we're going to take this one and we're going to see if we can simplify it. And the good news is that this is actually even easier than the one we just did, because over here you're dividing. Essentially, it's just like canceling. You're just going to cancel whatever you can with whatever's on the bottom, because division, when you're talking about regular numbers, is just plain old regular division. When you're talking about exponents, you do the opposite as you would when you multiply. When you multiply things with exponents, for example, if you have x to the second times x to the first, which is just x, so you would add the exponents. So that would be x to the third. When you divide, you do the opposite. When you have x to the second divided by, which is the same thing as x to the second over, so we'll just use over, that's probably a better way to do it, you just subtract the exponents, which in this case is 2 minus the 1, because there is none, and this becomes regular x to the first, which is the same thing as just plain regular x. So let's see how we would do something like this. So the number you can divide with the number. The number you can just say, for example, 36 divided by negative 2 is negative 18. So let's start by writing this negative 18. And the numbers, that means the numbers basically just canceled out, okay? Then you can say x to the third divided by x to the second, so subtract the exponents. X to the third divided by x to the second, so that's 3 minus 2, is x to the first. So we can just leave the x over here. With the y, it's slightly more complicated, because we have y to the fifth minus y to the seventh, or divided by y to the seventh, which means you subtract the exponents. 5 minus 7 is, of course, negative 2, and there are two ways you can do this. Either you can just say y, to the negative 2. That's one correct way of doing it. Another way you can do this is you can just leave it as over y to the second. In other words, this 7, you can just leave the bigger one, which is over here on the bottom. So you can say negative 18x, and you can leave it over y to the second. In fact, these two expressions are the exact same thing. Generally speaking, a negative exponent means 1 over whatever that number is. Just to give you some other examples, 8 to the negative 2 is the same thing as same thing as 1 divided by 8 to the second. 3 to the negative 3 is, of course, the same thing as 1 divided by 3 to the third. That's all a negative exponent means. So these two expressions are comparable. We had negative 18x, because it was x to the third divided by x to the second, y to the negative second. Or we can just say, really, what this term did. Let me explain it a little bit better over here. I'll just take this out over here, make it look a little bit better. Okay, here we go. Now, so what we could have done is just said negative 18, like we did, times x to the first, which is what we did, and multiplied, well, it's y to the negative 2, which is the same thing as 1 divided by y to the 2. And then if we multiply this, whenever you multiply two fractions, because they're next to each other, you can just put this on the numerator, so this becomes negative 18x divided by y squared, and that is your answer, or, I should learn to make a little bit of a better circle, or that is your answer. Either one would be equally acceptable. Our next section is factoring. And in order to do factoring, let me just review multiplication of polynomials, which is what we did a little bit before. So let's start with, again, what we did before over here. Let's take a quick example. Let's take, let's say x plus 7 times x minus 4. If we want to do something like this, we have to multiply. So when we want to do this, we have to multiply each term by each other term. So remember, we have the x times x, which was, of course, x squared. And then the outer terms, you multiplied, let's say, this term by this term, which is negative 4 times x, negative 4x. And then you have the inner terms, which is 7 times x, which is plus 7x, and negative 4 times positive 7 is negative 28. You may remember this from high school, something called FOIL, first, outer, inner, last. Now you can combine terms that have the same variable. In this case, you have this term and this term have the same variable. X squared you can't do anything with. Minus 4x plus 7x, well, that's positive 3x, because it's 7 minus 4, and minus 28, and this is your answer. Now, factoring is the exact opposite. Factoring is when you have this number to start, and you have to turn it into two binomials. So let's say you wanted to simplify or factor a trinomial like this. Now, in order to do this, what you need to do is do the exact opposite of what we did before. We are going to end up with two monomials. Now, the only way to do this is first you got to think of which two letters, which two factors are going to multiply up to x squared. And of course, in this case, there's only one possibility, and that is x and x. If there is a coefficient for the x squared, it gets a little bit more complicated, but in this case, it's relatively easy. Now, the next stage in making this determination about what these two numbers are is we need two numbers that are going to multiply up to this number up here. In this case, the 12. All the way over here, you see the 12. We need two numbers that are going to multiply up to the 12. Because, remember, the last two numbers are going to multiply each other when we multiply back out. So the first thing we need to know is we need to look at this sign over here. If this is a positive, then these two terms either both have to be positive or both have to be negative, because either way, two positives or two negatives will multiply up to a positive. If it is positive, like this, we can simply look at this sign, and if that's a positive also, then we know that both numbers have to be positive. If this number was a negative, then both numbers would have to be negative. So we're going to put in two positive signs. And the key here is, now that's the easy part. The hard part is we got to think of two numbers that multiply up to this number, multiply up to the 12 over here, but add up to the 8. Now, if we're thinking of numbers, this is maybe do a little trial and error. What are the different possibilities of numbers that multiply up to 12? Well, there's 12 and 1. There's 3 and 4, and there's 6 and 2, and that's pretty much it. There's no other possibility. Now, if we look over here, now we're going to need some combination over here of these numbers, of the 12 and 1, 3 and 4, and 6 and 2, that add up to 8. Now, of course, 12 and 1 don't add up to 8, 3 and 4 don't add up to 8, but 6 and 2 do add up to 8. So if we put the 6 over here and we put the 2 over here, now we've got our answer. In fact, the one way you can check your answer is you can multiply out and see if it works. You can multiply these two by each other and see if you come up with your original answer. The reason why we know it's the correct answer is because 6 and 2 multiply up to 12, and they add up to 8. Now, x, if we multiply it out just to make sure, x times x is x squared. Then we have the outer, which is x times 2, which is 2x. Then we have the inner, 6 times x, which is plus 6x. Then we have the last numbers, which is 6 times 2, which is 12. You can combine these two because they have the same variable. So we have x squared plus 2x plus 6x is 8x plus 12. If this is the same as this, then obviously we know we have the correct answer. Now let's try one where we have slightly different signs. Let's try a trinomial like this. Let's try, one second over here. Okay, let's try this one. Let's try x squared minus, let's say 7x plus 12, let's say. Well, here we start with the same way. If we're going to factor this into two monomials, we'll factor it like this. Again, the x and the x are the only things that are going to multiply up to x squared. Now here we've got a positive sign over here, which means we've got to do something that's going to multiply up to positive 12, but the middle sign is negative, so we're going to have to use one negative and two negatives that'll multiply up to the negative 12. Now, of course, we need the same two numbers that multiply up to positive 12 and add up to negative 7. Again, we've got the same three factors. 12 and 1 is a possibility, 4 and 3 is a possibility, 6 and 2 is a possibility. Well, if you think about it, if we're going to use two negatives, and they're going to add up to -7, 4 and 3 work. So if we say, for example, x minus 4, x minus 3, that will add up to -7, and it will multiply up to +12. So this will be your answer. If you want to check it, to multiply it out, x times x is x squared. The outer is -3 times x, -3x. The inner is -4 times x, -4x. And the last is +12 because it's -4 times -3. The -3 and x and the -4x can combine into -7x plus 12, and there is your answer. Okay. Now we can try one in the middle. Let's try x squared plus 3x minus 10. If we want to factor that, again, we use the same two monomials. Again, the x squared and the x squared. Now, over here, this sign is negative, which means that the only way to multiply up to a negative is to have a positive and a negative. So now we've got to find factors that will give you altogether positive 3x, but it'll multiply up to -10. What multiplies up to 10? Well, of course, you have 10 and 1, and you have 5 and 2. Those are really the only two options. And if you look, how can you get something along these lines that will add up to +3? Well, we can use, how about if we use the 5 and 2? If we use the +5 and the -2, well, that will multiply up to -10, and if you add them, +5 minus 2, which is 5 minus 2, you get 3. And again, just to check it, multiply first, outer is -2x, inner is +5x, last is -10, plus 5x minus 2x, combine those two into +3x minus 10, and away you go. And that's how to solve that kind of a problem. Now, sometimes you're missing those middle terms when you factor. Let me give you an example over here. What if you have, let's say, y, again, let me just do this over here. Okay, let's say you have y squared minus 25. Now, over here you have the missing x term. There's no term in the middle. Essentially, what this is sometimes called is the difference of two squares, because you're going to have two monomials the same way, but because there's no middle term, that means the two terms on the outside, the two second terms, are going to have to add up to 0 altogether, which means obviously you'll have the y and the y, just as we would before. And again, before I used x, now I used y. There's no inherent difference between them. Makes no difference. But what you can now, because this is a negative, one's going to have to be a negative and one's going to have to be a positive, and the last two numbers are going to have to be the same number, because they're going to have to add up to 0. So let's say, for example, if this was 10 and that was -10, that would add up to 0. You can't have these two numbers be different from each other, because the middle term is actually a 0 because it's absent. So we need the two numbers that multiply up to this last number. Of course, 25 is a perfect square. It's 5 and 5. So this is actually a very easy thing to do. You know, if we have x squared minus 81, let's say, again, we'd have x and x. We'd have to have a positive and a negative. They'd have to be the exact same number. In this case, of course, it would be 9. 9 and 9. That's called the difference of two squares, and if you get something like that, that's actually a fairly easy one to do. A little bit harder is where you have a cube number. Like, let's say, for example, x to the third power. Let me write that over here. X to the third power minus 8. Now this is actually, you got a whole bunch of missing terms. You got a missing squared term, and you have a missing plain x term. You just have a cube term, x cubed minus 8. This is what is called the difference of cubes, or I don't know if that's what it's actually called, but it's something similar to the difference of two squares. Now this is a little bit more complex. Now what you have to do here is you have to figure out what is the cube root of 8. In other words, what cubed gives you 8? And the answer, of course, is 2. You're going to have to get a perfect cube. Just to give you an idea, 2 cubed is 8, 3 cubed is 125, 4 cubed is, what, 256, excuse me. 5 cubed is 625. So whenever you get an example like this, it's going to have to be something like that. It's going to have to be either an 8, which is 2 cubed, or a 125, which is, I'm sorry, 1 second. 3 cubed is 27. 4 cubed is, what's 4 cubed? 4 cubed, we said, is 64. I'm sorry, I was wrong before. 5 cubed is 125. 6 cubed is 216, etc. Now, there's going to have to be a number that's a perfect cube. Otherwise, you're not going to be able to do this kind of a question. Now, the way to do this is not so intuitive, but so we'll have to go through it. So the first thing you have to do is you're going to use two parentheses. You're actually going to have a monomial, a binomial, which means two numbers times three numbers. The first one has to be the cube root of each one. So let's say x, because x to the x cubed is x cubed, obviously, minus 2. Because 2 cubed is 8. Now, in this term over here, you're going to have three terms. And the three terms are going to be, first, the same term that you had before, which the number that's going to have to multiply up to the first number. So in this case, you have x, and you have to have something that's going to multiply up to x cubed. So in this case, we're going to put x squared, because remember, x squared is going to be what's necessary to multiply up to this number. And in the middle terms over here, this is a little bit counterintuitive over here, but you're just going to have to really remember this. It's going to have to be two plus signs. Over here, you're going to have the same number. In the middle term, you're going to have the same number as this, except positive with the variable. So in this case, it would be 2x. Now again, you don't really necessarily have to remember the logic behind this, but the logic behind this is that the middle terms are going to have to cancel out. When you're going to do the 2, the negative 2 is going to have to multiply up with the positive 2. Kind of like the difference of two squares. Then the last term is going to have to be whatever you need to multiply this. You're going to have to, whatever multiplies up to this number in order to get the last number over here, which is going to be, which is negative 8. So, because remember, the last terms are going to have to be the same. The last terms are just going to multiply by each other to get this term over here. So in this case, it would be 4, because it's necessary to have a 4 to multiply up to negative 8. Now again, first of all, let's multiply this out just to show you how it works. Then we'll do another one, because I know it's really the sort of thing that you have to memorize. You might not have time to really worry about exactly why it works. So x times x squared is x cubed. Then let's do x times 2x is plus 2x squared. Then you have x times 4, so that's plus 4x. Now we're going to do it like we did last time. We'll do the last one lining up with the same things that they cancel, the same variables. So you have negative 2 times x squared, which is negative 2x squared. Then you have negative 2 times positive 2x, which is negative 4x. And then you have negative 2 times positive 4, which is negative 8. And notice, of course, what happens when you add these together. You have the x cubed. The positive 2x and the negative 2x cancel out. That's 0. Plus 4x minus 4x is again 0, and you're left with the negative 8. So let's try another one in order just to reiterate how you do this. Let's try, again, something very similar to what we just did. Let's try, for example, x to the third power, did it again, x to the third power minus 125. Now, 125, what cubes up to 125? 5, because 5 times 5 is 25. 25 times 5 is 125. So again, we're going to separate it into a binomial and a trinomial. So we'll put x over here, x minus 5. That's the thing that cubes up to it. Then over here, again, we're going to have the x squared, because that's going to be necessary to do x times x, which is x times x squared, which is x cubed. Then the middle term, again, they're both going to be plus. The middle term is going to be whatever's necessary to mirror this 5. So we'll call it 5 with the x. And then the plus thing is going to be whatever is necessary to multiply this up to 125, which is 25. And that is your entire answer. And again, just to make sure, we will check it by multiplying it out. X times x is x cubed. X times 5x is 5x squared. X times 25 is again plus 25x. Now let's do the second term. Minus 5 times x squared is minus 5x squared. I think you see where this is going. Minus 5 times 5x is negative 25x. And then negative 5 times 25 is negative 125. Sorry, 1 second here. All right, there we go. 125. And again, the x cubed comes out. These cancel, and you have 125 left, which is the same thing we had up here, so it means you got the answer correct. Before we move on to our next subject, I want to introduce you to a concept that is important for many different scenarios over here, and that is the concept of I. Now, I is it's really actually stands for the word imaginary, which seems a little bizarre to have an imaginary number in math, but in fact there are imaginary numbers in math. And what I means in math terms is the square root of a negative number, the square root of negative 1. Now, I'll give you an example for why this is. Let's say, for example, you have the square root of 16. Well, the square root of 16 is whatever squared will give you 16, which is 4. But there's really two answers, because 4 times 4 will give you 16, but also negative 4 will give you 16. Negative 4 times negative 4 is also positive 16. So this is sometimes referred to as plus or minus 4. That's how you would usually write the correct answer. Square root of 16 is plus or minus 4. Now, so the square root of 64, for example, of course, would be plus or minus 8. Square root of 49 would be plus or minus 7. Now, what if you have, for example, the square root of negative 16? Well, that's really impossible if you think about it, because nothing squared will give you negative 16. Negative 4 squared will give you positive 16, and positive 4 squared will give you positive 16. So this is impossible. It's an imaginary number. And so therefore what you would do is you would say, you would separate this into I, which is the square root of negative 1. You could separate this equals the square root of 16 times the square root of negative 1. You can always separate them if you like, because negative 16 is in fact the same thing as 16 times negative 1. So if then the positive 16 you can change into 4, and the square root of negative 1 you can just leave as I. I means the square root of negative 1. Now, of course, so you can leave things in terms of I, generally speaking. If you get the square root of negative 1, you can just leave it as I, because there's really nothing you can do about that. But let's take this one step further. What is, for example, I times I? Well, of course, that's I squared, like anything else. But let's figure what that means. I times I means the square root of negative 1 times the square root of negative 1, which means negative 1. The square root of negative 1 times the square root of negative 1, well, anything, the square root squared is the number itself. Obviously, the square root of 16 times the square root of 16 is just plain 16. Well, the square root of 16 is 4 times 4 is 16. So the square root of negative 1 times the square root of negative 1 is plain old negative 1. So if you're solving a complex equation and you get I squared, you can just change I squared into negative 1. So let's use an example. Let's look at an example in that respect. Let's say I give you a binomial that you have to multiply out. Let's say I give you negative 5. One day I'm going to stop doing that. All right, let's say I give you, let's say, negative 5 plus 4i times 3 plus I. Now, what they ask you to do is to leave in terms of a complex number. A complex number means you have a real number and an imaginary number. Anytime you have an I, you have an imaginary number. Well, let's see how to do this. This is just like any other binomial. We'd multiply out FOIL. First is negative 5 times 3, which is negative 15. Outer, negative 5 times positive I, which is negative 5i. Inner, positive 4i times 3, which is positive 12i. And then the last one, we've got 4i times I, which is plus 4 I squared. Well, let's see what we can do with this. Well, the negative 15 is the negative 15. Not a whole lot we can do yet about that. Negative 5i plus 12i, well, that's 12 minus 5. So we can say plus 7i. Why could we combine them? Because they've got the same variable. Well, that's not really a variable, but they've got the same term. Once they've got the same term, you can combine them. 7i. Now, 4i squared, remember, I squared is negative 1. So this is the same thing as 4 times negative 1. That's just the same thing as the I squared, which really is the same thing as negative 4. So we've got negative 15 minus 4, which we can combine into negative 19, plus 7i. And now we've got negative 19 plus 7i, or you can write it as 7i minus 19. It doesn't really matter. But either way, this is the best we can do, because there's really nothing else that we can do at this point, because we can't combine them. We've got 7 with the I, and we've got negative 19, which is a regular number, and that's how we would leave our answer. This is what's called a complex number, which is sometimes written in terms of a complex number as a plus bi. In other words, some regular number plus a number that's a coefficient of I. Now we're going to move on to really a brand new component of the review course, and we're going to move on to solving equations. Until now we've been discussing manipulating numbers, which of course is very important. You can't solve an equation without knowing how to manipulate variables and manipulate numbers. But now we're actually going to move to algebraic equations. We're going to start with the basic ones, and as they move on, they're going to get more and more complicated. Alright, so let's start with some very, very basic equations. Hopefully this will be reviewed to everybody. If you have, let's say, x plus 3 equals 7, and you want to know what x is, you're always solving for the variable in an equation, well, you need to get rid of everything except for the variable. In this case, you need to get rid of the 3. You subtract 3 from each side, and you have x equals 4. Common sense. Alright, if you have, let's say, 3x equals 18, well, you also need to get rid of everything from the variable. You want to get the variable all by itself. How do you get rid of the 3? Well, the 3 is multiplying times x. Well, you have 3 times x. So if you divide by 3, it cancels. And whatever you do to one side, you do to the other side, and you have x equals 6. If you have a little bit something to drop more complex, let's say, for example, you have 3x plus 20 equals, let's say, 5, just for argument's sake. Alright, now here you have to do both steps. You need to isolate the x. You always want to isolate the variable. So first thing you need to do is get rid of this term, get rid of the 20 term, so that you can have the x term by itself, and then you can worry about completing the isolation. So for example, you can subtract 20 from this side and 20 from that side. So you're canceling the 20 minus 20, and you have 3x equals 5 minus 20, which is negative 15. And then you can isolate x by dividing each side by 3. If you divide each side by 3, x equals negative 15 divided by 3, which is negative 5. And of course, you can always check whether your answer is correct by substituting. I'm not going to do it in longhand, but we can do it in our heads. 3 times negative 5, which is negative 15, plus 20 equals 5, which of course is correct. So that's basically how to do a very, very simple algebraic equation. Now let's look at something where you have fractions involved, which makes it just a little touch more complicated. Let's say I give you something like this. And again, they could be more complicated or less complicated, but either way, they're all going to be the same basic idea. Let's say we have x over 3 plus x over 4 equals, I don't know, let's say 7. I think that'll come out nice and even. Okay, good. So we have x over 3 times plus x over 4 equals 7. Now, in this case, it's going to be very hard to manipulate this if we still have these denominators. What we can do is we can figure out what's called the LCD, or the least common denominator, and that is what number can we multiply everything by to get rid of all the denominators. What number goes into all the denominators? Well, over here there are only 2 denominators. There's 3 and 4. And if you think about the smallest number that can divide evenly into both of them is 12. Now, 6, for example, 6 divides into 3, but it doesn't divide into 4. 8 divides into 4, but it doesn't divide into 3. 10 doesn't divide into either one. 12 is the one that uses both. And again, the great thing about algebra, and the one thing that's always going to work, is that you can always do anything to one term as long as you do it to all of the rest of the terms as well. So I'm going to put the LCD as 12 over here, and I'm going to multiply all the terms by 12. So I'm going to say 12 times x over 3 plus 12 times x over 4 equals 7 times 12. First term, okay, you can cancel the 12 and the 3. 12 divided by 3 is 4, and the 3 cancels out, so this becomes 4x. The second term is very similar. It becomes, you cancel the 12 and the 4. 12 divided by 4 is 3, so this becomes 3x equals 7 times 12, which of course is 84. So then you just solve it like you would a regular equation. You can combine the x terms. Again, you want to try to isolate the x terms so you can combine them as much as possible. 4x plus 3x is 7x equals 84. Isolate the x by dividing each side by 7, and you have x equals 12. And if you want to check it, well, let's go back to our original equation. We had x, let's say we substituted 12 for x and 12 for x. Let's see if it works. Well, what's 12 divided by 3? Is a 4, of course. What's 12 divided by 4? Is a 3, of course. And 7. Does 4 plus 3 equal 7? Of course it does. And then we have solved the equation. Let's, along the same vein, make it a little bit more complicated. Let's try something like this. Let's try 3x divided by 5 minus, and this time we'll make the fractions be a little more complex, something like this. X plus 3 divided by, x plus 2, divided by 3. Okay, so now we've got a question that again is a little bit more complicated, but it's the same basic idea. First we figure out what is the least common denominator here, the LCD. Well, let's see. We got 5, we've got a 2, we've got a 3. Let's see, what goes into 5? Let's go by 5s. 10. Well, 10 doesn't divide into 2 or 3, so that is not going to work. 15 divides into 3, but it doesn't divide into 2. 20? That doesn't work either, because 20 doesn't divide into 3. 25 doesn't divide into either. 30 is really the smallest thing that's going to work. 30 is going to, the one way you can find a common denominator is by multiplying them all out. 5 times 2 times 3. That doesn't always give you the least common denominator, but at least it gives you, a good start. But 30 over here is the least common denominator. So I'm going to multiply all of these terms by 30. 30 times 3x over 5 minus 30 times x minus 3 over 2 equals 30 times x plus 2 over 3. Let's get our canceling done over here. Well, this becomes 6, because 30 divided by 5 is 6. This becomes 15, of course, and this becomes 10. Now over here, you got to multiply all these terms by whatever number their coefficient is. So for example, you got 6 times 3x minus 15 times x plus 3, and x minus 3. Remember, you got to multiply it by the whole term. You can't just multiply it by the x alone, equals 10 times x plus 2. Okay, well, 6 times 3x is 18x. Minus 50, you got to multiply out, you have to distribute, so negative 15 times x is negative 15x. Then this times this term, negative 15 minus 3 is positive 45 equals 10x, again we're distributing, this times this, and then this times this is plus 20. Okay, no x term over here. All right, now we've got an equation at least. We don't have a denominator anymore. And from this point, it's really just like solving any old equation. We've got 18x minus 15x, so we can combine that. Obviously, you want to combine as much as you can. So we've got 3x plus 45 equals 10x plus 20. Now, when you've got both x terms and constant terms on both sides, you want to try to get all the x terms to one side and all the numbers to the other. So it doesn't really matter which way you go, but let's say, for example, negative 45 to each side, minus 45 from each side, excuse me. And so we'll get all the numbers over to the right, and then we'll get the letters to the left by subtracting 10x from this side, which cancels, and subtracting 10x from this side. All right, so we've got 3 minus 10x is negative 7x. The 45's cancel, the 10x's cancel, and now we've got 20 minus 45, which is negative 25. And of course, the way to solve this is by dividing by negative 7, and divide this by negative 7, because that way you isolate the x. So you've got x equals negative 25 divided by negative 7. Negative divided by a negative is a positive, and so you're left with 25 over 7. Now this, you cannot, this doesn't divide evenly. So you could, for example, write this is 3 4/7. I mean, I suppose you could do that, but generally speaking, you don't have to. You can just leave it as 25 over 7. And that is basically how you do an equation. Just again, this so far is still pretty easy, but we're just kind of using algebra to manipulate numbers. And remember, in algebra, you can always do anything to one side as long as you do it to the other as well. Next, we're going to look at word problems. Word problems are where algebra becomes useful, but it also can get a little complex because it makes you actually think about what you're trying to do rather than just mechanically applying principles. So what we're going to do is we're going to have 3 examples that I'm going to look at. First one is this one. You are choosing between 2 health clubs. Club A offers membership for a fee of $50 plus a monthly fee of $5. Club B offers membership for a fee of $30 plus a monthly fee of $7. After how many months would the total cost be the same? Let's go to our whiteboard. I'm just going to copy and paste this question so we can look at while we're doing the answer. Okay. And let us put this over here, and now we can actually go ahead and work on the answer over here. Again, let's read it carefully. You're choosing 2 health clubs. Club A offers membership for a fee of $50 plus a monthly fee of $10. Club B has a monthly fee of membership fee of $30 plus a monthly fee of $7. How many months would the total cost be the same? Now, I know that many people didn't learn it this way, but the way I learned to do word problems is always to start off with what's called a let statement. A let statement is when you defined the quantity that you're looking for. In other words, what exactly is it that we're looking for over here? It can be very useful. Let's take a variable. We can call it x, we can call it y, it makes no difference. But let's take our variable as x. What is the thing that we're wondering about? What are we going to try to look for over here? Well, the question is how many months will the total cost be the same? And then later on we'll figure out what the total cost for each club is. So let's say the x equals the number of months. It's important to define what our variable means, the number of months until it becomes the same. Alright, so once you've defined that, I think you've really done half the battle. Now it's a question of writing an equation to illustrate the relationship that we're looking for. So the first Club A has a membership fee of $50 plus a monthly fee of $10. That means $50 to start plus 5 times the number of months, because every month is going to be a monthly fee. So we're going to say 5x, which is 5 times x. 5 times the number of months, is the same as Club B. Remember at the end we looked at, it said the question was, when will the total cost be the same? So this equals Club B, which is $30 initially, plus 7 times the number of months, because it was $7 a month. You see how this works over here? $50 was the initial, plus 5 times the number of months, because it's $5 a month. $5 per month, so x being the number of months, it's 5 times x, 5 times the number of months, is the same, at least that's what we're looking for, when are they going to be the same, as $30 initial fee plus $7 a month. Okay, well then this we would do like any regular equation. Get all the x's to one side, all the numbers to the other. Let's get the x's to the left and the numbers to the right. I generally like to do it that way. It doesn't really matter, but so let's subtract 7x from this side in order to cancel, and we can do that as long as we subtract 7x from that side. And then we want to get the numbers over to the right. So subtract 50 to get that to cancel, and subtract 50. 5x minus 7x is negative 2x equals 30 minus 50, which is negative 20. And then to get x by itself, you can divide by negative 2. That will cancel, because that's the same as being multiplied by the x. Divide by negative 2. And x equals negative 20 divided by 2. Negative times divided by a negative is a positive, and 20 divided by 2 is 10, so you have x equals 10. We haven't totally answered the question, so x is the number of months, that's 10, okay, that's our answer to the first question. What's the total cost of each club? Well, that should be pretty simple. It's after 10 months, so either side will give us the answer, 50 plus 5x, and x is 10. So 50 plus 5 times 10 is 50 plus 50, which is $100. The other side should also give you 100 because they're equal. 30 plus 7 times 10, which is 30 plus 70. And so the answer to part B is $100. Okay, second type of word problem. This is also a very simple one. This is also a simple problem. This is really a percent problem, but it's the same basic idea. After a 25% reduction, you purchase a television set for $380. What was the television's price before the reduction? Okay, well, the first thing you need to know is what percentage is. 25% is the same thing as 0.25. 100% is the same thing as 1. You know, there theoretically could be 200%, which is the same thing as 2. 125% is 1.25, etc., etc. Basically, in order to get a percentage, you just slide the decimal point over 2 spots. 25% is the same thing as 0.025. Now, 25% reduction is essentially the same thing as saying that you're paying 75% of the price. So really, your question here is 75%, which is 0.75, of what is 380? Because you purchased it for 380. And so the 380 is 75% of the full price. So let's say, for example, x equals, I probably should write it on top, but okay, x equals the full price. Again, just for our let statement, we could say let x equal the full price. So 75% of the full price is, and in algebra, by the way, is always the same thing as equals, for common sense reasons, is 380. Okay, we can divide each side by 0.75. Divide by 0.75. And you can do this on a calculator. There's no inherent reason why not. You can do it longhand if you like, or you can do it on a calculator. And I'll just do it on a calculator over here. Let's see, what do we have? We've got 380. You can't see it actually, but let me get the calculator up just to show you what I'm doing. Sorry, here's the Windows calculator. All right, so what do we got? We got 380. Divided by, that's the fraction sign over here, 0.75, and we have $506.67. It rounds off. You can round off the nearest hundredth. So over here, so our answer would be $506.67. Maybe a little bit of an odd regular price, but if that's what the question says, then that's what the question says. And that would be our answer. And finally, we've got our third word problem that we're going to do together, and maybe the most complex, but it really just is the same basic idea as we discussed in the last two. An elevator at a construction site has a maximum capacity of 2,800 pounds. If the elevator operator weighs 265 and each cement bag weighs 65, how many bags of cement can be safely lifted in one elevator trip? Now you can probably solve this without algebra at all, but let's do it the algebraic way, just to make sure. Again, we're going to start with our let statements, so we can say let. Well, what quantity are we looking for over here? Let's try y this time, just for kicks, instead of x. Let y equal what? Well, we're looking how many bags of cement. So let's say the number of bags of cement. Whoops. Don't know why this isn't working. Well, of cement. Sorry about my sloppy handwriting over here. All right. So we've got let y equals the number of bags of cement. So we're looking at 2,800 is the total amount. So we'll say 2,800. And that is what? What is 2,800? Well, we don't know how many bags of cement there are. So we'll say each bag weighs 65 pounds. So it's 65 times the number of bags. And the number of bags in our equation was y. Plus, of course, we got to account for the person. The person weighed 265. The elevator operator weighed 265. So you can write it the other way also, 265 plus 65. You can write it, 265 plus 65y equals 2,800. Either way is equally valid. It's just a little bit more pleasant to write it from left to right. It just makes it a little bit easier in the long run. But the point is that the way this works, you have 265, which is the pounds, the elevator operator, plus 65 times the number of bags, which is what we're trying to count over here, can only be up to 2,800 altogether. So how many can be lifted in one elevator trip? Well, again, you would solve this as just like you would any other equation. You'd say minus 265, we're going to try to isolate the y, minus 265. So we've got 65y equals 2,800 minus 265, which is 2535. Now, you've got to isolate y again. How do you isolate y? How do you get y by itself? Again, divide by 65, because that cancels. Divide by 65, and we can do it. Again, we can do it on a calculator. We don't have to do it on a calculator, but we can. Let's just say 2535 divided by 65, and you get 39. Okay, very good. So let us say that our answer over here is x equals 39. Put a nice little box around it, and away you go. So you can have 39 bags of 65 pounds each, and plus the elevator operator. If we want to make sure that we're correct, well, let's see if it works. We've got 65 bags times 39 pounds each. Now 65 times 39, of course, is 2535, plus the person, which is 265, and that will equal, of course, 2,800. So we know we have the correct answer. Okay, and the next step we're going to do is solving quadratic equations. We're going to continue solving equations in general, and we're going to look at the type of equation known as a quadratic equation. All a quadratic equation means is that there is an exponent. There is, for example, instead of just being something like, let's say, x plus 7 equals 10, instead you have something like x squared plus 7 equals, let's say, 11. Okay, now if you have an equation like this, and again, this is obviously a very, very simple one, but the first step is you need to do to isolate the x. So for example, you can say negative 7, x squared equals 4, because you're subtracting from this side, subtracting 11 minus 7. Now in this case, in order to get rid of the exponent, you want to know what x is, so you can take the square root of x squared, which is plain old x. So once you do that to one side, you do it to the other side as well. So you have the square root of x squared, which is just plain x, equals, so what's the square root of 4? It's 2, but that's not the entire answer, because it really, as we discussed before, could be positive 2 or negative 2. The square root of with negative 2 times 4 is negative 2 times negative 2 is positive 4, and positive 2 times positive 2 is positive 4. So the answer is plus or minus 2. We've got two answers, plus 2 or minus 2. In fact, generally speaking, all quadratic equations are going to contain two answers. You're going to have two possible answers. So that is a simple one. Let's take one a little bit more complex. Let's take something like, one second, let me just make sure that this is set up properly. Okay, we've got 2x squared minus 11 equals 87. If we want to solve this, we solve it essentially the same way as we would any other equation. Well, you want to isolate the x. So the first thing you want to get rid of is the whole 11 term. How do you get rid of the 11 term? Well, it's minus 11, so to cancel it, you do plus 11. You do it to one side, you've got to do it to the other. So you've got 2x squared equals 87 plus 11, which is 98. Now you've got to isolate the x again, so you want to get rid of the 2. You can get rid of this 2 first by dividing by 2. Now you've got x squared equals 49, and then you can take the square root of both, and so you have x equals the square root of 49, which is plus or minus 7. Very important. If you just put in 7, you only have half a correct answer. If you only put in negative 7, you have half a correct answer. The answer is plus 7 or minus 7. Now, unfortunately, this really relatively simple solution only works when you only have two terms. You have the squared term and you have the number term. It doesn't work, for example, if you also have a plain x term, which is where the quadratic equations get a little bit more complex. So let's take a look at a quadratic equation that does have a regular x term. Let's say we have an equation like this. We'll say x squared, let's say minus 6x minus, let's say, minus 22 equals 18. Let's say we have something like this. Now the problem is, if we tried to isolate x, we wouldn't be able to do it. I mean, I'll show you what would happen if we tried to isolate. We could add a 22 to each side, add 22, and now we'd have x squared minus 6x equals 18 plus 22. Yeah, 18 plus 22 is 40. Now, see, the thing is, now what do we do, though? You know, we can't just take the square root of this, because if we tried to take the square root of this, we'd have to take the square root of this also, the 6x, and the square root of 6x is not a perfect square. In fact, 40 is not a perfect square either. So that wouldn't work at all. So let's see how we would do this. First of all, let's get rid of whatever we've done so far. Let's get rid of this, get rid of that, start over, and we're going to write the 18 over there. Alright. Now, in order to do something like this, where you have the three terms, you have the squared term, the x term, and the regular term, what you need to do is you need to set the whole thing equal to 0. You need to get 0 on this side. You need to get all three terms on the left side and only a 0 on the right side. How do you get a 0 over here? Well, you can just take away the 18. How do you take away the 18? Just simply subtract 18. And whatever you do to this side, you have to do to that side. And of course, I'm putting it on this term because this is the one that it can be combined with. X squared minus 18 does nothing. Negative 6x minus 18 does nothing. The 22 and the 18 can be combined. So now on this side, we've got x squared minus 6x. Negative 22 minus 18 is negative 40. Equals 0. Okay, so now we're in business. Now, what you can do over here is you can simplify this into, this is a trinomial, you can make it into two binomials, and each one of them is going to work. We're going to make two binomials, in other words, two numbered parentheses, and they're going to equal to 0. Now, the reason why this will work, of course, is because if you have two numbers multiplying by each other, and either one of them is 0, then the whole thing is going to be 0. So let's take a look. Let's factor this like we would any other number. We need to multiply up to the x squared, so we're going to say x over here and x over here. Now we need to look at this sign. This is a negative, which means that the two signs in the binomials are going to be one positive and one negative. Now remember, we need to multiply up to negative 40 and add up to negative 6. What are our roots for 40? What multiplies into 40? Well, we've got 40 and 1. We've got 20 and 2. We've got 10 and 4. We've got 8 and 5. And I think that's pretty much it. Those are the four possibilities. Which one of them will give you negative 6 when you add? Remember, you got one positive and one negative. Well, you can see right away there's one of these where there's a difference of 6 between them. And that, of course, is this one, the 10 and the 4. So we need a negative 6. So if we make the negative 1 10 and the positive 1 4, well, now we've got a difference of 6, because minus 10 plus 4 is negative 6, and of course they also multiply up to negative 40. Okay, now each one of these terms is equal to 0 for the reason I said before. If either term is 0, then the entire thing is 0. So you could actually separate them into two separate equations. X plus 4 is 0, and also this side, x minus 10 is 0. Again, because either one can be 0 for the entire thing to be 0, because anything times 0 is 0. This equation is easy to solve. Minus 4, so x equals negative 4. That's one answer. And the other answer, again, just as easy, add 10 to each side. X equals 10. Okay, so we've got our two answers, negative 4 and 10. Both of them will work, by the way. If you start with our original equation, let's start with let's start up here. Let's try negative 4. Let's do it outside. Negative 4 squared is 16. Minus 6 times minus 4 is plus 24, because negative times negative is positive. Minus 22, does that equal 18? Oh, better. 16 plus 24 is 40. 40 minus 22 equals 18, so that works. Now let's try it with 10. We have x squared, which was 100, minus 6 times x, which is 6 times 10, which is 60, minus 22, and of course 100 minus 60 is 40, minus 22 is 18, which is what we wanted, so both roots work. Unfortunately, sometimes the equation that you're going to use is just not going to factor out properly, and then you're going to have to do something a little bit more complex, a method called completing the square, which is a lot harder than the one we just saw. Let's take an example. Let's say we have, let's say, x squared plus 4x plus 1 equals 0. Well, it's in the right form, so we don't have to do anything in that respect. The problem is this is not going to factor in. If you try to factor into two binomials, it's simply not going to work. You have x and x. That works so far. But now you need something to multiply up to 1 and add up to 4. Obviously, that's not going to work, because the only thing that multiplies up to 1 is 1 and 1, and 1 and 1 don't equal 4, unfortunately. 1 and 1 equal 2. So we're going to have to take that away and start something else. And the only way to do this is, and this is a formula you're just unfortunately going to have to remember because there's really no other way to do it. You can figure it out by using a fairly complex formula called x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Now again, I know that looks very, very complicated, and you want to know what are all those b's and all those c's. Well, a is the coefficient, the number next to the x squared. B is the coefficient of the x, and c is the constant. C is the number over there. So in our case, for example, a is a 1, because there's nothing next to the x, so there's a 1. B, remember, remember that's a 1 and not a 0, because 0x squared would be 0. So this is x squared is the same as 1x squared. The b is the thing next to the x, which is a 4, and the c, of course, is also a 1. Now, applying this formula, what you would need to do, you would say x equals negative b, which is negative 4, plus or minus the square root of b squared. 4 times 4 is 16, minus 4ac. 4 is 1. 4 times a, which is 1, times c, which is also 1. So it's 4 times 1 times 1, which is 4. All divided by 2 times a, which is 2 times 1, which is 2. So essentially what you have, and 16 minus 4, of course, is 12, the square root of 12. Now, unfortunately, the square root of 12 doesn't break down into anything. If it did, then you wouldn't need this formula in the first place. The square root of 12 is not a perfect square. So there are really two answers over here. You have x equals negative 4 plus the square root of 12 over 2, or negative 4 minus the square root of 12 over 2. Those are your two answers. Remember, there's always going to be two answers in a quadratic equation. And there's really nothing you can do over here. You know, you can't cancel the 4 and the 2 because you got that plus sign in the middle over here that's messing it up. You can only cancel when something is being multiplied, not when you have a plus sign over here in the middle. And you can't really break down the 12. You can simplify it a little bit, but that doesn't really matter that much, I don't think. But for our purposes, that's pretty much all you can do. So you just gotta put a circle around the whole thing, and that's your answer. X equals negative 4 plus root 12 over 2, or negative 4 minus root 12 over 2. Again, this is just the formula that you just have to remember, unfortunately. Negative x, this is the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac, all, the entire thing, over 2a. Next, I want to look at absolute value. Absolute value is a concept in math where you essentially ignore the sign. Something could be positive or negative. For example, just to take a really, really simple way of looking at it, if I have, let's say, the absolute value of 6, absolute value, the way you symbolize it is you put lines on either side. Well, the absolute value of 6 is 6 because, well, they're just... 6, it's just you take away the sign. Now in this case it's positive, so it just stays positive. Absolute value of negative 3 is 3. Absolute value measures how far you are away from 0. 6 is 6 away from 0, 3 is 3 away from 0. If you have, for example, the absolute value of 3 minus 7, well, 3 minus 7 is negative 4, and so the absolute value of negative 4 is just plain old 4. Now, so that's, fairly simple. Now let's take a look, though, at equations regarding absolute value. And I'll look at a simple one first, and then maybe one that's a little bit more complex. Okay, so first let's start with something very simple. Let's say we have the absolute value of x equals 7. Now, common sense indicates right away that what is x? Well, x could be 7, then, x is 7, or x could be negative 7. Because if x is negative 7, well, the absolute value of negative 7 is positive 7. So whenever you have an absolute value of a variable, whenever you have the absolute value of x over here, all you do is you just simply can get rid of the absolute value, and you can say x, but the other side is plus or minus 7. It could be plus 7, or it could be negative 7. Just like with quadratic equations, absolute value equations all have two answers each. Now let's take one a little bit more complicated over here. Let's take the absolute value of 3x minus 11 equals 1. All right. Now, again, the thing with this is that we don't know what x is, obviously. The absolute value means whatever is on this side could either be positive or negative. So there are really two separate equations that we can use to solve this equation. Either one will be correct, or really both of them will be correct. We can have 3x minus 11 equals 1, or 3x minus 11 equals negative 1. Either one is correct, because the absolute value could be negative, or it could be positive and still be the same thing. So let's solve each equation separately. Add 11 over here to isolate the x. We still have 3x. 1 plus 11 is, of course, 12. Further isolate the x by dividing by 3. X equals 12 divided by 3, which is 4. Okay? Now, let's try this side. Now you'd have to add 11 again. Add 11. 3x equals negative 1 plus 11, which is positive 10. Divide each side by 3 to isolate x. And you have x equals 10/3. You can change that into 2 2/3 if you like, or you can just leave it as 10/3. And if you want to check it, you want to make sure it's right, well, let's look at our initial equation. Let's take this one first. 3 times 4 is 12. I'll do it down here. Let's check it over here. So the first one is 3 times 4 minus 11 equals 1. Let's see, 3 times 4 is the absolute value of 12 minus 11, which is 1. Absolute value of 1 is 1, which of course is correct. Let's try the other one. We have 10/3. This one we had 3 times 10/3 minus 11 equals 1. Well, the 3's cancel over here. So we have 10 minus 11. And of course, 10 minus 11 is negative 1. Is the absolute value of negative 1 equal 1? The answer, of course, is yes. So they both work. And that's how you solve and really get the two correct answers for an absolute value equation. The next subject is graphing on a number line. This is actually a very, very easy subject to begin with. It can get a little bit more complex when you get into graphing various solution sets, but fundamentally it's a very simple concept. Graphing on a number line just means putting your specific numbers on a number line. Now, number lines start at negative infinity and finish at positive infinity. So, for example, if we have a line, a number line, number lines start, and I'll put arrows on each side because they're infinite in both directions. A number line starts over here at negative infinity. So if we put a number let's say here, sorry that they don't look so good, but anyway, I'll just put a whole bunch of numbers here for our number line. 0 can be somewhat in the middle, because 0 is in the middle of the number line. If it starts at negative infinity and ends at positive infinity, so 0 would be over here. And then over here you would start the positive number, 1, 2, 3, 4, 5. And over here you would start with the negative numbers. Okay, if you are asked to put a point, so for example, let's say you're asked to put in two numbers, -3 and +2. Well, very simple. Just put a circle over there for the -3 and put a circle over there for the +2. Let's say you are asked to represent an equation. Let me just get rid of that. And let's say the equation is something like, this is what's called an inequality when you say something like, we've been doing equals until now, but let's say we say, for example, x is greater than 3. If you wanted to represent that in a number line, let's do two of them. Let's say x is greater than 3, and x is, I'll tell you what this means in a second, but let's start with this one. X is greater than 3 means that x can start over here, and it can go all the way on this side of the number line, but not on that side. So if I want, let's use a different color in order to make it a little bit more clear. Here, let's use red for this line. X is greater than 3. Now, for x to be greater than 3, you say you can put a circle over here. Now, I'm not going to fill in the circle. The reason why I'm not going to fill in the circle is because x cannot be 3. X has to be greater than 3. And to represent what x can be, I would draw a line in this direction, fill it in a little bit, and put an arrow at the end of it. And this represents that x is greater than 3. The other one over here, the one on the right side, which I am going to make in, which I'm going to put in purple, this means smaller than or equal to -1. So I'm going to go to the -1 over here, and this one I am going to fill in, because this says x can equal -1, as it can either equal or be smaller than. So then I would put a circle over here to represent -1, and then I would have a line going in this direction with an arrow at the end that illustrates that x can be smaller than -1 all the way to negative infinity. Sometimes, by the way, you might be asked to do both at the same time. Let's take a third example for let's use a different color. Let's take an example of -4 is smaller than or equal to y, which is smaller than or equal to 2. Well, now you've got two. Now you can actually graph the solution set on this axis, on this graph over here. And I'm rather than drawing a whole new one, I'll just do it on the same one. This will be a different color, so hopefully it'll be clear. Well, y is greater than or equal to -4. So I'm going to put a circle by the -4, and I'm going to fill it in because it's greater than or equal to. It's also the other side is 2. And I'm also going to fill that in because that's also greater than or equal to. And the number's got to be somewhere in between. So I'm going to use this green line. Again, sorry for the mess over here. But this green line, I could just make it a little bit neater, actually. If I just did this. Whoops. Whatever. Anyway, not that neat as it is. All right. The point is that looks really, really, really messy. Let me try to draw it a little bit better. I'm sorry. So I have to fill in the 2 over here, and then I know what I'll do. I'll use this feature, and I'll just draw a line like this. And now this indicates on the number line that y, the green number over here, is greater than -4. -4 is smaller than or equal to y, and it can go all the way up to 2 or be equal to 2. Next, we're going to get into something that is a little bit more advanced as far as algebra goes, but the truth is really not any more complicated than what we've been doing so far. And that is the idea of a function. Now, functions are mathematical relationships where one variable leads to another variable. One thing that could change, by definition, leads to something else. Just to give you an example of a basic equation of what would be a function, you could say y equals x plus 1. This is a function because one variable leads to another variable. For example, we all know if x is 2, well then y is 3. If x is 10, then y is 11. If x is a million, then y is 1,000,001. That's why it's the very simple example of a function. Functions are sometimes, now this equation is written with 2 variables, x and y. When y is a function, it's also sometimes written like this. F of x equals x plus 1, which means a function of x. In this case, there's no difference between this and this term and this term. Y is a function of x in this case, and f of x is a function of this case. If you had, for example, z equals 3y plus 7, it would be just z is a function of y. When y changes, z changes too. And so it would be just as correct, for example, to say f of y equals 3y plus 7, because whatever this term is a function of y. There are a couple of rules regarding functions, though, that are important to discuss. Basically, in terms of determining what is a function and the 2 elements of a function, which are the function's domain and the function's range. A function's domain is what the initial variable can be. The range, I'll write those 2 words over here, a function's domain, let me write it up here, sorry. Okay, you got a function, you've got a domain, and a domain leads to a series of possible results, which are a range. So let's say we just give that example before, we had f of x equals, x plus 3. Okay, well, the domain, which is what x can be, is pretty much anything. The domain starts at -infinity, and it goes all the way to +infinity, because x can be anything. The range can also be anything as long as it's 3 more than the domain. Whatever the range is, it can lead all the. It's also the range in this case is also negative infinity to positive infinity. But it can be any number in the world as long as it's 3 more than the x. So those are the two basic concepts of a function. The thing that makes something a function and the thing that is required of every function in order for it to be a function is that there has to only be one variable in the range for every variable in the domain. In other words, every value of x has to only have one possible value of y. Now this of course is a function because whenever x changes, y is going to change too. If x is 1, y is 4. If x is 2, y is 5. If x is 3, y is 6. If f is 4, y is 7. Or f of x in this case. But either way, when every value of x is going to have a different value of f of x. Every value of x is going to lead to a different result over here. So let me give you some examples in terms of what is considered a function and what would not be considered a function, and what their domain, and range would be. All right. Let me just get rid of this over here. And we'll try a series. Let's say we have a certain set of relationships. Let's say we have, again, sorry about that. Let's say we have an x column, and we'll have it a y column or an f of x column. Either way, let's say x is 7. And y is then y is 4. If x is 6, then y is 12. If x is 5, then y is 11. If x is 4, then y is 1,000. Again, I don't know if it's possible to have this sort of to write some sort of an equation that would have this sort of thing, but that's not really what's important. What is important is that this is clearly a function because every value of x has a unique value of y. So because if x is in this case, by the way, let's take a look at what the domain would be and what the range would be. The domain, well, the domain is with all the x values. So in this case, the domain would be x, so that x is this is the symbol for containing the domain. You use the ellipses over here. X is 7, 6, 5, or 4. Okay, now the range, what's the range over here? Well, what are the possible values for the range? 4, 12, 11, and 1,000. So for this particular function, whatever it is, and again, there might be some crazy equation that you could write that would fit all these criteria, or there might not be, I don't know. But the thing is that whatever this is, you have a certain set of values possible in the domain, and you have a certain set of values possible in the range. The same thing, I drew it one way, I drew it in graph form before, but the same thing could be written in terms of points. For example, if I have, let's say, 3 points, I've got 6, 4, 5, 7, and 12, 1. The first, just like in any other point in terms of a graphing point, the first value is the x value, the second value is the y value, or the f of x value as it may be. So in this case, since the x value is the 6, the 5, and the 12, we would say the domain is 6, 5, and 12. Sorry about that. Okay, the range would be 4, 7, and 1. Now, let's change this a little bit, and let's see if well, I'll give you 2 more examples, and I want to discuss whether they're considered functions or not. Let's say we had 6, 4, and we had 5, 3, and we had 7, 4. Look at this. Now see this, you have 2 possible x's that are going to give you the same y. In other words, a 6 gives you a 4, a 5 gives you a 3, a 7 gives you a 4. But this is still a function. The reason why it's still a function is because every unique value of x gives you a specific range, gives you a specific y. Just because they're the same doesn't make it a non-function. Even if, for example, you had, if you had a chart, let's say, you had the x over here and you had the y over here, and let's say you had some sort of an equation or some sort of a relationship that would make, let's say, x's, you had 0, 1, 2, and no matter what your relationship was, the y would be 2, 2, 2. This is still a function, because every value of x has only one value of y. They could be the same as each other. In fact, generally speaking, you can see, let's say we had a function where y equals 0 times x, which is, which is a reasonable, it's a legitimate equation. Now, if you notice, no matter what x is, y is always going to be 0. If x is 0, well, it's 0 times 0. If x is 1, then it's 1 times 0. If x is 2, then it's 2 times 0. No matter what x is, y is always going to be 0. That's still a function. So it's perfectly legitimate, for example, to say, let me erase this to get a little bit more room. It would be perfectly legitimate to say f of x equals 0x. It is a function, but regardless of what x is, f of x is always going to be 0. That's fine. However, if two different functions, if one value in the domain, if one x leads to two possible different y's, then it's not a function. Let's do another little chart over here. Let's say we say 3, 4, 3, 5. And on the y column, we've got 1, 2, 3, 4. So we've got a 3 leads to a 1, a 4 leads to a 2, 3 leads to a 3, 5 leads to a 4. This is not a function, because in this case, we've got two x's that can lead to different y's. There's no way to write this equation where f of x equals something x that's going to lead to this kind of a relationship. So this would not be a function. You still have a domain and range. What's the domain? Well, the domain is 3, 4, and 5. And you have a range, which is 1, 2, 3, and 4. You can also say 1 to 4, I suppose. But actually, it's more correct to say 1, 2, 3, and 4 for reasons I don't want to get into. But the point is that that this is not a function. It's not a function because you have two possible values in the domain that can lead to two different ranges. So that would not be a function. So let me give you one example. I'll give you a set, and you can look at it and tell me whether this is a function, and what the domain and range is. Let's see. Let's do this. Let's see. We have 10 and 4, -2, 4, -1, 1, and 5, 6. Now, in this example, first of all, what is the domain? Well, the domain, we've got 10 is the x value. The x value. So we've got 10, we've got -2, we've got -1, we've got 5. You can put them in order if you want, but you don't have to. The range is what the y's can be. Y can be 4, and then another 4, so that's already there, and a 1 and a 6. Is this a function? The answer to that is yes, it is a function. Because you do not have two different domains that'll give you the same range. If, for example, this would have been 10, let's say we cross this out and we make this a 10, well, then it's not a function, because now you've got two 10s that lead to different results. You've got two x's that lead to different y's. One other thing you're expected to be able to do with functions, which is actually very, very simple, is to simply, if they tell you what a function is, then you need to be able to substitute it for x. I mean, it sounds a little bit, abstract, but let's try something like this. Let's say I tell you that f of x equals 3x plus 3. And let's say I ask you to get f of 7, f of x plus 5, and f of negative 2x. Let's just say I ask you to do this. Again, it may look a little complicated, but this is really extremely easy. If they ask you if a function of x is 3x plus 3, well then no problem. If you know what the function is, just substitute. So in this case, f of 7, just substitute 7 for x. So it would be 3 times 7 plus 3. 3 times 7 is 21, plus 3 is 24. So f of 7 is 24. In this case, f of x plus 5, well, substitute 3 times x plus 5 plus 3 equals, well, 3 times x is 3x. Remember, you have to distribute 3x plus 15, because 3x plus 3 times 5 plus 3. You can combine the 15 and the 3, so you've got 3x plus 18. So an f of x plus 5, based on this function up here, f of x plus 5 is 3x plus 18. What about negative 2x? Again, very simple. We'll just substitute the negative 2x for the x plus 3. So that's 3 times negative 2x is negative 6x plus 3. So all this really asks you to do is substitute whatever is in the parentheses for whatever the x is. Because if x is this, well then a function of x, if you change whatever's in parentheses, you just got to substitute. Very simple. Now we're going to start with graphing. Now, when I teach you graphing over here, I can only do it on the computer. It's a little bit more limited. Hopefully you'll be able to have a piece of graphing paper that you can practice on the side, because it is a little bit different when you do it with paper as when you do it on the computer. And we're going to start with graphing linear equations. Actually, I have the graph paper over here, but I'm going to put the graph paper aside for 1 second, just so that we can discuss a little bit about graphing linear equations. Now, linear equations means an equation that's going to give you a straight line. Now, a regular, plain old, run-of-the-mill graphing equation is going to be a linear equation. A regular graphing equation is a function, as we discussed in the last section, and it has a y value and an x value. For example, something like, the simplest linear equation that I could think of is, let's say, y equals x. Now, if y equals x, that is graphable, and maybe we'll discuss a little bit later on how to graph it. But the first thing that you need to know is that equations can be a lot more complicated than that. And so let's say, for argument's sake, you have an equation that's something like y equals 6x plus 3. We'll discuss how to graph something like this a little bit later on. But before we do, there are some points to remember about equations that are linear that you have to graph. First of all equations have to have a y and x value, obviously. Second of all, you want to make sure that all equations are in this form: y equals something x plus or minus something. That is what is known as y equals mx plus b form. M is what is called the slope, and b is the y-intercept. That means where it's going to cross the y-axis, and again, we'll see what that means a little bit later on. So in this case, this is y equals mx plus b form. You know right away, since it's y equals mx plus b, that the m, namely the slope, is 6, and the y-intercept, or the b, is 3. If your equation is not in y equals mx plus b form, For example, let's say your equation is 2y minus 2 equals 4x. Well, you can't graph this yet, or at least it's not in appropriate form yet. You can't figure out the slope and the y-intercept from this alone. What you need to do first is solve for y, which means isolate y. How do you isolate y? Well, first of all, you can get rid of the 2 terms, so you can add 2 to each side. So you have 2y equals, let's say, 4x plus 2. Remember, you can't combine these because this has a variable and this doesn't have a variable. Now you need to get rid of the 2 in order to get y by itself, and to do that you can divide everything by 2. Divide all 3 terms by 2, and 2, 2, 2, and you have y, because these cancel, equals 4x divided by 2, which is 2x, plus 2 divided by 2, which is 1. Now we've got our equation. Now this equation, of course, is y equals mx plus b form, which means right away, even before you graph it, we know that the m, which is the slope, and we'll discuss what the slope is in a few minutes, is 2, and the b, in other words, the y-intercept, is 1. All right, now let's go back to our graph paper, and let's graph this equation here. Let's discuss how to graph it. Here is our graph paper, and we'll write down our equation over here. What was our equation? Y equals 2x plus 1. First thing you got to do when you graph is you have to draw your set of axes. Your axes, will draw them over here. They can go, let's say, across like this. Something like this. And the appropriate form is to put arrows on the end of each one. Okay, well, that didn't work. Well, anyway, you can put an arrow here, an arrow here. All right. Well, anyway, it should. Well, let's just do it right the first time. From now on, I won't bother to do this because it's taking time. But the truth is, you should really put a arrow here and an arrow here, just to illustrate that the graph goes on forever and ever. And then you should label your axes. This is going to be your x-axis, your horizontal axis, and up here is going to be your y-axis, which is your vertical axis. Okay, that's your x, that's your y. So the question is, how do we graph something like this? Graphing is actually very easy. All you have to do for something like this is you can draw your little chart over here. This is the way I always learned how to do it. There are probably simpler ways to do it, but this will always work. You can guarantee that. You can put an x and a y on opposite sides of the chart. Whoops. Okay, it's not exactly the straightest chart in the world, but it will. Let me make this a little straighter. Whoops. All right, it's fine. Okay. And you can usually, I would use 3 or 4 points. Hopefully you recall a little bit about this. And now, y in this case is 2x plus 1. So I'm just going to write 2x plus 1 in the middle over here. I'm going to pick some random values for x. Let's say 0, 1, 2, and 3. Usually 3 points should be enough, but we'll use 4 just for kicks. And then you can just substitute whatever x is over here to figure out what y is. It's 2 times x, which is 2 times 0, plus 1. So y, of course, is 1. Now over here, it's 2 times 1, which is 2, plus 1. So y is 3. Over here, it's 2 times 2, which is 4, plus 1. So y is 5. And then you've got 2 times 3, which is 6, plus 1, and y is 7. Of course, you could do this all in your head if it's a simple question like this. If it gets a little more complex, a chart where you have the equation in the middle actually helps a lot. Anyway, we've got 4 points over here. We've got x is 0 and y is 1, so our first point is 0 and 1. Our second point was x is 1 and y was 3, so we have 1 and 3. Our third point was 2 and 5, and our fourth point was 3 and 7. Let's plot all of these points. Now this over here in the middle, that's the origin. That's the 0. Then the x's get positive on this side. For example, this is 1, 2, 3, 4, 5, etc. The y's, and I'm sorry, and the x's go negative on this side, -1, -2, -3, -4. The y's go positive as they get up, 1, 2, 3, 4 on the vertical axis, and this is -1, -2, -3, -4, etc. You can also go by 2's or by 5's or whatever it is, depending on what your equation needs are. Anyway, so let's plot our first point. Our first point is 0, 1, which means we're 0 on the x-axis and 1 on the y-axis. So that would be right over there. So I'm going to plot this point over here. Hopefully you can see that. Let me make it a lighter color so you can see it a little bit better. Actually, then you're not going to be able to see the other ones when they're on the white. So let's make it green. I think green will show up pretty well regardless. All right, there we go. Anyway, so we've got the 0, 1 over here because the x is 0 and the y is 1. Next, the x is 1 and the y is 3. So the x we're going to go over 1 and the y will move up to 3. Then we're going to go to 2 and 5, which is up here. Again, that's 2 over and 5 up. And the next one was 3, 7, which is going to be up here, 3 over, 7 up. Now, one thing you absolutely have to make sure is that it's a straight line. If it's not a straight line, it means you did something wrong. It has to be a straight line. And so once you've finished plotting your points, now you can graph it. Now you can get out a straight edge, a ruler, get out something like that. Let's use this color, and let's make sure that we can start over here and draw a line up through here. Let's make sure the line is straight. In fact, now I'm going to take it from here and go further down this way. We have to make it completely straight, of course, or else it's wrong. All right, so now we've got a straight line over here. In fact, then we can, again, the appropriate thing to do is to put arrows on the end and whatever. All right. Anyway, that's an arrow. Fine. And then the correct thing is actually to write the equation on the line. Why is that important? Because if you have multiple equations on the same axis, you want to be able to keep control. So what was this equation? This equation was y. Well, 1 second. Let me just get back to this utility here. What was this? This was y equals 2x plus 1. Now we've graphed a line. Simple enough. And one of the great things that you can do with graphing is you can actually have two separate equations. And later on we're going to learn a little bit more about solving systems of equations, but having two separate equations where they each have both an x and a y can be a little complicated, or you can just put them on the same graph and see where they cross. I mean, let me give you an example over here. Let's say we've got two equations. Let's say we have, let's see, I have it written down over here, 3x minus y equals 13, and we have y equals negative 2x plus 7. Okay. This is a system of equations. It's impossible to figure out from either equation what x and y are. There are two different variables. If you have two different variables, you can't say, you can't say that either of them could be either number because there are many, many solutions for each one. I mean, just to give you an idea, if I say, for example, x plus y equals 7, obviously you don't know what x is, you don't know what y is. X could be 6 and y could be 1. X could be 5 and y could be 2. X could be 1,000,000 and y could be negative 999,993, etc. There's just no way to know. If you have another example, on the other hand, if you have, for example, y equals x plus 1, well, now all of a sudden you can solve them because you've got two different equations. In this case, I mean, you'll have to trust me on this one, but y would be 4 and x would be 3, and that would be the solution to both. But to determine that, one way you can do it is you can simply graph them both. You can simply put them both in the same piece of graph paper and see where the lines intersect, and that should be able to help you make a determination. Now, before you do that, you want to make sure that both of them are in y equals mx plus b form. This one is in y equals mx plus b form. This one already is y equals something x plus or minus something. So for the bottom equation, again, it's not going to be relevant for this problem, but we know the slope, the m, is -2, and the y-intercept is 7. For the top one, though, this is not y equals mx plus b form yet. We need to isolate the y. How do you do that? Well, we can... anyway, we can subtract 3x from each side, minus 3x. So we have negative y still, equals, I put the x term first, negative 3x plus 13, which stays by itself. The problem with this is that you don't have it yet in y equals mx plus v form, because y is still a negative. You need y to be a regular plain old y. So to do that, you can simply multiply by -1. Just change the signs. Change all the signs. Make everything negative. Remember, whatever you do to one equation, you can do to the other. So you have y, and change this sign. This becomes positive 3x, and this becomes negative 13. So now it's y equals mx plus b form. The slope happens to be 3, and the y-intercept happens to be negative 13. Okay, but let's graph both of these equations, and let's see what the answer is, what the solution is. This top equation over here, what is x, what is y? One way there are different ways we could do it, but let's try to do it through graphing both equations. All right, let's bring the graph paper over here, and I am going to graph both lines. Now, first let me draw my axis. Again, let's start over here and draw this. I won't label them because, again, we did that last time. You get the drift, hopefully. Let me make this a little bit further down. All right. Okay, fine. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. See, I made the y-intercept over here is going to be negative 13, which means that, okay, well, you know, we'll use different. Okay, anyway, so let's use different values. Okay, the point is, let's graph each one. If you don't know what I just was talking about, don't worry about it. The thing I was just talking about is over here, if you remember the bottom equation, we said that was y equals 3x minus 13. Well, this number is the y-intercept. The y-intercept is the number that it crosses the y-axis. That's the number that it's going to cross. So it's going to cross the y-axis way down here below the bottom of the page. But okay, well, let's not worry about that now. We can go ahead and solve the equations over here. All right. So what were our two equations? Let's do one up here and one toward the bottom of the page. The first one, which was, I'll make this a little smaller since it's a small area, y equals 2x plus 7. And on the bottom we had y equals 3x minus 13. All right. Now remember what we did last time? We did the little chart, the x over here, the y over here. Okay. Let's do, for x, we'll do 0, 1, 2, 3, and let's see how this goes. What was the equation? Y equals negative 2x plus 7. So negative 2 times 0 is 0, plus 7 is, of course, 7. That's the y-intercept. Negative 2 times 1 is negative 2 plus 7. That's positive 5. We had 2 times negative 2 is negative 4 plus 7. That's positive 3. And you had 3, which is negative 2 times 3, which is negative 6 plus 7. That's positive 1. So we've got 4 points over here. We've got 0, 7, 1, 5, 2, 3, 3, 1. How about the bottom one over here? Let's put the x over here, the y over here. You can really use any points you like for x. You don't have to use 0, 1, 2, and 3. In fact, I'm not going to use 0 because 0 is going to come off the charts. So let's use 1, 2, 3, and 4. Okay? What's the equation? 3x minus 13. Okay, 3 times 1 is 3, minus 13 is what? Is negative 10, right? Next we have 3 times 2, which is 6 minus 13, which is negative 7. Then we have 3 times 3, which is 9 minus 13, which is negative 4. And we have 4 times 3, which is 12 minus 13, is negative 1. All right, so let's plot the bottom one and plot the top one. I'll make it a little thicker, and I will change the color when I graph the lines. In fact, let's use a red line to graph this one, just to keep them separate. And for the bottom one, we will use that will use green, and we'll use a red one for the bottom one. All right. So let's get the green. All right. So for this one we had, what was our first point? Our first point was 0, 7, right? So that's 0, 1, 2, 3, 4, 5, 6, 7. Okay. Our second point was 1, 5, 1, 1, 2, 3, 4, 5. Our third point was 2, 3. That's 2, 1, 2, 3. Our fourth point was 3, 1, which is over here. Okay, that's all our points. Now let's fill out the line. Again, we'll start it over here. We'll make sure it's straight. As straight as we can make it. Okay. Whoops. Let's draw it again. Alright. And then I'll draw it up the other way just to make sure that we... Remember, lines go forever in each direction, so really we should put arrows at the end of each, but again, you get the point. Oh, let me make a little arrow here, and a little arrow here. Alright, so this is our first line. Our y equals, and again, normally I would write alongside of it, y equals negative 2x plus 7. Alright, now let's try the other one. Where's the other line? Well, this one we were going to do in red, right? Okay. So what are our points? Our first point was 1, negative 10. So 1, negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, good. Almost ran out of space, but we didn't. Okay, I'm sorry. I gotta change this, make it a little thicker so you can see it. I'll just make the line right over here. Okay. Then we had what? 2, negative 7. That's here. I just 1, 2, 1, 2, 3, 4, 5, 6, 7. Then we had 3, negative 4, which is here. Whoops. All right, whatever. And 4, negative 1, which was here. You can see that's right on the other line, actually. Okay, so now let's draw our equation. All right, let's start here. Let's make sure that this is absolutely straight as possible. And there we go. These are our two lines. Again, let's make the arrow here, arrow here, arrow here, and arrow here. Okay, now where do they cross? Well, let's see. They cross at 1, 2, 3, 4, and negative 1. So the point at which they cross, let me write this down over here in a different color because that's the solution. They cross right here at 4 and negative 1. So the solution, we have x is the first number always, so x equals 4 and y equals negative 1. Let's go back and see if this works. We had 4 and -1. Let's go back to our initial equations, which are over here. Let's try the first one. What did we get? We got, let's say, x equals 4, y equals -1. Let's try the first one. 3x. Okay, 1 second. Okay, 3x is 3 times 4, which is 12, minus y, and y is -1, minus -1, which is the same thing as +1, equals 13. And 12 plus 1, of course, is 13, so that works. Now let's try the second equation. Y, which was -1, equals -2 times 4 plus 7. Let's see if that works. -2 times, so we have -1, equals -2 times 4 is -8 plus 7. What's -8 plus 7? -1, of course, so that works as well. So this is one way to solve a system of equations by putting them both on the same graph. Okay, next I want to go through the slopes and y-intercepts. We've been discussing that a little bit as we've moved along. As we've discussed recently, the general rule about the form of an equation, the correct form of the equation, is y equals mx plus b, where y and x are variables. Obviously, y and x change from point to point, but m is the slope, and b is the y-intercept. The y-intercept is where the line crosses the y-axis. In other words, where a line that goes like this would cross. Let's just just take some random lines over here. If we had a line, for example, that went like this. Whoops. We want to use the line utility, obviously. If we have a line that goes like this, let's just say let's take this line for example. Let's see what we could figure out about this line. Now, first of all, we know the y-intercept because where does it cross the y-axis? Well, let's see. This is the y-axis, so we have 1, 2, 3, 4, 5, 6. So it crosses the y-axis at 6. So for this particular equation over here, let's say the y-intercept, the b, is 6. If it's down here, it could be in the negative numbers, but in this case, it happens to be 6. The next thing that is important is the slope. The slope is sometimes known as the rise over run. How far does the line go up for every box that it goes rightward? In other words, how many y's does it go up for every one x that it goes up? Well, in this case, we can figure this out many different ways. Over here, for example, right at this point, we're at 0, 6, which is the y-intercept, we see that it goes to here, it goes up 1 as it goes over 3. So in other words, it rises 1 for every 3 that it moves over. And then again, rise 1 over 3. And it can start all the way back here. Up 1 over 3, up 1 over 3, up 1 over 3, up 1 over 3. So this slope in this case is actually, the slope, is actually 1 over 3. Just to give you an idea of what a steeper slope would look like, something like this. Let's take this, again, let's use the line utility again. I'll use a different color. Let's take this line, for example. Let's take a line down here. A line like this. Now, a line like this, let's use this color. What's the y-intercept for this one? The y-intercept for this one, well, where does it cross the y-axis? At 0. At 0, 0. It actually crosses at the origin, which is 0, 0. So this crosses the y-axis when x is 0. So for the bottom equation over here, or the bottom line over there, the y-intercept is 0. And what's the slope? Well, let's see. How many does it go up for every one that it goes over? Well, let's start down here. It looks like it goes up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. So the slope in this case is actually, 2. Well, not a very, I'll draw it a little bit nicer over here. So this is 2. Okay, let's look at what like a negative slope looks like. These are both positive slopes. Let's take over here, for example. Let's look at this. Oops, again, make sure to use the line utility. Okay, there we go. Let's try this. Let's try a line like that moves something like this, the purple line. Now the purple line, first of all, let's see what its y-intercept is. It hits the y-intercept over, hits the y-axis over here when x is -2. So for the purple line, let's go in the bottom left-hand corner over here, the y-intercept is -2, and the slope is also negative. Because for every 1 that it goes over, it goes 1 down. 1 over, 1 down. 1 over, 1 down. 1 over, 1 down. So the slope down here is actually m equals -1. Now, the thing is, as soon as you have the slope and the y-intercept, you can write the equation for each one. Let's write the equation for the purple line. Well, it's y equals mx plus b form. We know the m is -1. We know the b is -2. So let's say y equals mx, which is -1, so you can say -1x, which is the same thing as -x, plus b, which is -2. So this is actually the equation for this line down here, y equals -x minus 2. Let's take the red one. The red one, we had the b equals 0, and the m was 2. So if we wanted to, for example, write the equation for the red one, well, let's write the equation for the red one. Let's put it over here, and we would have y equals 2x, because the m is 2, plus 0, or we can just leave it at that. We can leave it at 2x because plus 0 is meaningless, so we can just leave it there. Then, if we wanted to use the brown one up here, well, we said the y-intercept is 6, and the slope is 1/3, so it would be y equals 1/3 x, or x over 3. You can do either one. You could either say first of all, the y-intercept is 6, so you can say y equals x over 3 plus 6, or you can say y equals 1/3 x plus 6. Either one is correct. Probably easier to say it this way, because then it's easier to see what the slope is. Now, if you know 1, and you don't, one common example of a question that they give you is where they give you a y and an x value, but they don't give you either the y-intercept or the slope. As long as you have a y value and an x value, and you have a slope or a y-intercept, you can find the other one. Let me give you an example of what I'm talking about over here. 1 second, let's get rid of this, and let us bring in the example over here. Okay, sorry this is spelled wrong, the word equation over here, but you get the point. Write an equation for the line that passes through 3 and 12, and is parallel to the line whose equation is y equals 3x minus 7. Now, I didn't mention it before, but parallel lines mean they have the same slope. Parallel, parallel lines means the same slope. So, for example, if I have y equals 2x plus 7, and another line is y equals 2x minus 4, they're different lines, obviously, but they run parallel to each other. Which, if you had a graph over here, and again, I'll just, I'm not going to draw a whole graph, but I'll draw a little bit. Let's draw 2 little axes over here. Okay, excuse me. Okay, let's say we drew, so y equals 2x plus 7 would be a 2 slope. Let's draw the lines in green. So that it would be a 2 slope, the y-intercept was 7. Whoops. Excuse me. Let me redraw the x-axis. If we had an x-axis like this, and so y equals 2x plus 7 would be a pretty steep slope, because y equals 2x means it goes up 2 for every 1 over. So it looks something like this, let's say. let's say it would look something like this. It would cross the, let's say this is the 7 point. Again, we have no numbers there, but let's say that's the 7 point. The bottom one, y equals 2x plus minus 4, that crosses at the minus 4. That crosses at the y-axis down here, but it would look similar in terms of how the line itself looks to the equation on top. In other words, the lines would run parallel to each other. They both have the same slope. They'd go up approximately the same way, the same direction, the same steepness, so to speak. The only difference is where they cross the y-axis. Obviously, the top one crosses at positive 7. The bottom one crosses at negative 4. All right, so let's take a look at this question again. We have write an equation for the line that passes through 3 and 12 and is parallel to the line whose equation is y equals negative 3x minus 7. So first of all, every equation for a line, we're going to want to write it in y equals mx plus b format. Y equals mx plus b. Now, we have the m, because it says that it's parallel to the line whose equation is y equals 3x minus 7. Now remember, the coefficient of the x is the slope, so the m is 3. So we know that this is going to be y equals 3x plus something, plus b, but we don't know what b is. How do we figure out what b is? Well, we have a point. Y and x are going to change, but we know that at least at this point, they're 3 and 12, so we can plug those in and solve for b. So we have y equals 3x plus b. Now in this case, we have x is 3 and the y is 12. So we'll say 12 equals 3 times 3 plus b. Now let's solve for b. 12 equals 3 times 3 is 9 plus b. I think it's pretty obvious where this is going. To get the b alone, we can subtract 9 from each side, and 3 equals b. So the y-intercept is 3. So if we wanted to write this equation, we would say y equals 3x, because that's the slope, plus 3. And this is our equation. Obviously, y and x change depending on the point, but the slope is always 3, and the y-intercept of this line is 3 as well. And again, that could be negative, that could be fractional. It just happens to be in the example that we put over here that would not be the case. By the way, and just for kicks, let's graph this just so I can show you how it works a little bit a little bit easier. First of all, okay, so we're going to graph this equation that we just solved. Let's put the x-axis again, put the y-axis. Again, you would normally put an arrow over here, arrow over here, arrow over here, arrow over here, and then and then you'd mark the x and y-axis. But okay, but let's take a look at the equation that we just finished working on. All right, so we figured out that the equation was y equals 3x plus 3. Now let's do our little chart, and we'll show you how a slope 3 line looks in real life. Whoops, okay, x, y. 3x plus 3 was the equation, so we'll write 3x plus 3 in the middle over here. And again, we'll use our standard 0, 1, 2, 3. Okay, 3x plus 3 is 0 plus 3. Notice that the 0 always means that the y is this number. That's why it's the y-intercept, because when x is 0, you only have this term left over. That's why it's the y-intercept. Then 3 times 1 is 3 plus 1 is 6. 2 times 3 is 6 plus 3 is 9. And then the third one is 3 times 3, which is 9, plus 3 is 12. So we've got 4 points. We've got 0, 3. We'll put that point over here. We've got 1, 6, which is up here. We've got 2, 9, which is up here, and 3, 12, unfortunately, is going to be too high, so we're not going to be able to get it. It's going to be somewhere up the top over there. Notice, by the way, remember back in the original question, which I'll scroll back to over here, one of the points was that it passed through the line 3, 12. And in fact, when we graphed it, of course, one of our points was 3 and 12, which makes sense, because if it passes through that, it has to go through, well, that has to be one of the points. All right, so let's draw our line. I want to illustrate how a line looks when, let's start it up here. And we're going to make sure that it's perfectly straight. And, okay, there we go, that should work. All right, this is our line. Again, let's do the arrows just to be correct. There we go, and then you can, so y equals 3x plus 3 is our line. Notice how steep this is. This is a 3 slope. It goes up 3, 1 over, up 3, 1 over, up 3, 1 over. Then we've got the y-intercept over here, that's 0, 3, and then it keeps going up 3, 1 over, up 3, 1 over. And it passes through the point 3, 12 eventually. Okay, before we move on to our next major topic, I want to cover one more thing about functions. We started to discuss functions a little bit, and we discussed how, generally speaking, every general equation is a function. You know, for example, if you had f of x equals, excuse me, wrong side of the pen. Let's see, f of x equals x plus 3. This is a function, of course, whose domain is unlimited, and whose range is also unlimited as well. The domain x could be anything, and f of x could be anything also. Now, there are some exceptions, and the main exception, the one that's most important and the one that you're going to be tested on, is that a function is undefined when a denominator is 0. That's a general math principle. We all know that, let's say, 6 divided by 3 is 2. 12 divided by 4 is 3. What's 0 divided by 3, or 0 divided by 4, or 0 divided by anything, is 0. Now, what is, for example, 6 divided by 0? The answer is it's undefined. There's no answer. It's a null set, which means it doesn't exist. The reason, by the way, is very simple. When we had 6 divided by 3 equals 2, the reason for that is because, well, 6 divided by 3 is 2, because you need a number that multiplied by this will give you this. 2 times 3 will give you 6. If you had 12 divided by 4 equaling 3, well, that's because 3 times 4 will give you 12. If you had 0 over 3, well, that's 0, because this times 3 will give you 0. On the other hand, what if you have 6 divided by 0? What times 0 is going to give you 6? The answer is nothing. It doesn't exist. They just put a null set over there. That means it doesn't exist at all. So a function is undefined when the denominator is 0. So if I say, for example, f of x equals 2 over 0. I'm sorry, that doesn't make any sense. I say f of x equals 2 over x. Okay, well, x can be anything. You know, this works. This could, function. There could be y, like f of x, which could be another variable, could be anything. Works for anything as long as x is not 0. So the way I would write this, I would say the domain of this. The domain of this function is x, whatever x happens to be, as long as, you can put a little thingamabob over here to indicate that's the domain, as long as x does not equal 0. Okay. So what this just tells you is that as long as this is a function, this is a defined function, it's a legitimate function, as long as f is not 0. So let's give you a slightly different example. What if I say f of x is equal to 7 over x minus 3? Well, now x can be 0. That's fine. As long as if x is 0, then the function is 7 over negative 3, which is negative 3/7. That's fine. What can x not be? What's it impossible for x to be? Well, x can't be 3. Because if x is 3, then the denominator is 0. So then I would say, if I wanted to say what the domain is over here, the domain is x, again, so that x is not equal to 3. All right, now let's make it a little bit more complex to show you the sort of question you're going to be tested on in terms of just this sort of concept, how they would test this sort of concept. Let's say I have something like f of x equals 2 over x plus 4 minus 17yz. And again, I'll just tell you in a minute why I do that. Actually, you know what? Never mind. I don't want to introduce different variables. That would just make things more complicated. Don't worry about that. X minus 5. Okay. All right. Now, so now we've got a function. We've got two parts of the statement, which is fine. The only thing is we can't have any denominator equal 0, because as long as one denominator equals 0, the whole thing becomes messed up. The whole thing becomes undefined. It's impossible. So, what can x not equal? X cannot equal -4, because then this equation would have a denominator of 0, and x cannot equal 5, because then this equation would equal 0. So, for example, I could say the domain is, so the domain over here would be x, so that x is not equal to -4, and in addition, x is not equal to 5. That would be the domain. If something becomes a little more complex, well, then you might have to set the entire thing equal to 0. You might have to set the entire denominator equal to 0 in order to figure out the answer. You know, let's say, you know, what we had before in terms of quadratic equations. This really is another way that they test you on quadratic equations. So, you know, let's say you have f of x is equal to 17 divided by x squared minus 7x minus 10, something like that. So they ask you, what is the domain for this? So we have to find out what x cannot be. X can't be anything that'll give us a 0. How do you define give us a 0? Well, let's set the bottom equal to 0. Let's say x squared minus 7x minus 10 equals 0. Now this is just like a regular quadratic equation, like any other quadratic equation. Two monomials equals 0, x. Actually, I'm sorry, this should be a plus. That won't work if it's a minus. Yeah, it wouldn't work. It wouldn't work if it's a minus. All right, it's fine. So let's say that's a plus. So you'd have to. This is a plus. So you'd have to. Both terms would have to be minus because they'd have to multiply up to 10, and this is a negative number. And of course, the answers are 5 and 2. 5 and 2 add up to -7. -5 plus -2 is -7, and they multiply up to positive 10 because -5 times -2 is positive 10. Solve each for 0. Okay, so in this case, x is going to equal 5, and in this case, x is going to equal 2. So both of them are going to be correct. So essentially, if x is 5, the bottom is going to be 0 altogether. And in fact, if you think about it, let's see, 5 times 5 is 25, minus 7 times 5, which is 35, plus 10 is 0. And if it's 2, 2 times 2 is 4, minus 7 times 4 is 14, so that's -4. -4 plus 10 is also 0. So either way, the thing is going to be undefined. So if I wanted to do the domain, I would say domain equals x, so that x is not equal to 5, and x is not equal to 2. And then I would have the domain of my function. Now this is a tough one. This is a situation where you have f of x equals x plus 7 over x cubed minus 2x squared minus 9x plus 18. Now the first thing you see on the bottom over here, obviously they ask you for what value, you know, what's the domain of x. What's the domain of f of x? Now, the problem, of course, with this one is you got to set the entire thing equal to 0. You got to figure out the entire bottom being equal to 0, just like we did before. So the easy part is saying, okay, fine, no problem. X to the third minus 2x squared minus 9x plus 18 equals 0. See, now, you take one look at this and you say, hold on a second, how can we do this? We can't factor this. This is a quadrinomial. It's got 4 numbers over here, and we certainly can't factor it into 2 binomials so easily. This one, you can do something very interesting. You can actually start factoring out of each of these 2 terms whatever you can. in order, you'll see what happens. Look at whenever you get a quadrinomial like this, whenever you get four things like this, try to factor out of each term what you can. The first two things over here, x cubed and 2x squared, you could factor out an x squared from each one. In other words, let's say if we were eliminating the things on the right side, we're only going to use these two. So we can factor out an x squared. We can say this is x squared times x minus 2. Why is that again? Because you're pulling out an x squared from each one. If you pull out an x squared from the x cubed, remember x cubed really means x, x, x. So we just took out two of them to put over here, and we took out the x squared here to make this x minus 2. And the reason why this works is because you can also pull out something to make this into an x minus 2 as well. If you have 9, now if you want to do this one, minus 9x plus 18, you can factor out a negative 9. You can say, for example, minus 9 times, well, you can pull out a negative 9 of this, x, and 18 divided by 9 is 2 as well. So you can pull out a, I'm sorry, whoops. See, I did a plus, but of course I needed to do a minus, because positive 18 divided by negative 9 is negative 2 equals 0. So now look at what we have over here. Now we've got x squared times x minus 2 minus 9 times x minus 2. Whenever you have the same variable, and it sounds strange, but the x squared and the negative 9 have the same variable. They both have the x minus 2. So you can turn this into an x squared minus 9 times x minus 2. It would be just like if I said, 2 times x minus 2 plus 4 times x minus 2 is the same thing as 6 times x minus 2, because it's the same variable. So this is x squared minus 9 times x minus 2. Now we can factor. Look at this. X squared minus 9 is the difference of two squares. So we can change this into two binomials, x and x. Remember, there's no middle term, which means it has to be positive and negative the same number, which in this case, of course, is 3. X plus 3, x minus 3. We still have the x minus 2 equals 0. Now we've got three terms multiplied by each other equal to 0, which means how many answers we're going to get? We're going to get three answers. Why? Because each term is enough to make the entire thing 0. If this one is 0, well then it's 0 times something, which is 0. If this one is 0, then it's something times 0 times something, which is 0. And if this one is 0, then it's something times 0, which is 0. So let's set them all equal to 0. X plus 3 equals 0, x minus 3 equals 0, x minus 2 equals 0. So this is x equals negative 3, this is x equals positive 3, and this is x equals positive 2. So now what's the domain here? So any of these values, negative 3, positive 3, and positive 2, are going to get you 0 on the bottom. So what's the domain? Well, the domain is x. Again, let's do the squiggly thing here. X, so that x is not equal to negative 3, x is not equal to positive 3, and x is not equal to 2. Again, so this was a tough one. You may want to watch it again. The idea here is that if you have four materials, they're only going to give you this if you can factor out enough to make it work like this. You factor out an x squared from the first two terms, you factor out a 9 from the second two terms, and you get the same base, you get the same x minus 2. Then you can combine them because of the fact that they have the same variable. So it's x squared minus 9, which is over here, times x minus 2. Then you can separate the x squared minus 9 to the difference of two squares, x plus 3, x minus 3, set them all equal to 0, and you have your three answers for which this function is undefined. Let's head back to graphing now for a little bit, and now we're going to talk about graphing quadratic equations. Before, we used graphing to graph linear equations, which means equations that gave rise to a line. That worked when there were no squares involved. Everything was just, y equals something x, mx plus b. Well, when you have a square involved, when you have a quadratic equation, then it becomes a little bit more complex. And rather than having a line, you have, we'll see how this works, obviously, but you're going to get what's called a parabola. Let's take a look at what a parabola looks like. I'll tell you, when you graph a, let's draw a set of axes over here again, just very quickly. Whoops. Okay. Set of axes. Remember, a quadratic equation. I'm sorry. Let me just draw this again. Okay. A regular equation, a linear equation, would look something like this. A quadratic equation is going to look like a U. It's going to look something like this.